observed with. And David's even treated them like a Renaissance friendship book. He's got people write in his logbooks. There you go, David. I'm talking about you again.
Yeah. And hello, everybody. And I had to go out and get my sunspots before the sun got too low. And so I'm back. And Scotty, I want to congratulate you on inviting Randall to come here. I think that was a masterstroke. And I hope you'll be able to persuade him to be a regular contributor to the Global Star Party.
Here, here.
Absolutely.
Scott is an innocent bystander in some way. The real blame belongs to Karim, I'm afraid.
Well,
No, it's all Scott. It's all
great.
Scott. I'm just the middleman.
And what I would do, thank you for that praise, David. Is unmerited, but I'd save your opinion, Scott, till after this.
yeah.
We're going to have a fun time tonight. It's going to be fun.
Yeah.
Oh yeah, and Scott, thank you for putting these damn things on.
Oh,
I should have said that earlier.
It is my pleasure. It really is.
And they're not damn things. These excellent.
They're amazing things.
It's the presenters that make it so amazing, you know. Otherwise, it'd just be like static on the other end. So we could
just be actually
an old TV, turn it to channel whatever 12, and then tell people that the 3% of that static is a result of the echo of the Big Bang or something, and just run that for an hour.
If it was you and David having a conversation for 2 hours, I would still tune in. That would be amazing.
We may do that someday.
Yeah, let's do it.
Okay, here's a question for you, and I'm sure David Eicher he's probably done this already. Scott, does there exist a good interview about you in print? Just your experience at Mead and later with your own company.
David Levy wrote a article about me that appeared just as I was transitioning from Mead Instruments to Explore Scientific. So that
answers my question and exposes my ignorance. Thank you.
Right.
I think David used to run features on the various people making them.
Yeah,
the various people producing stuff.
Yeah, it was in Sky and Telescope for about 20 years. I did that.
Yeah, astronomy too, though, I think.
And in astronomy as well.
Yeah. I remember the one about Al Nagler in particular. Why, I don't know, but there's a bunch of them. Anyways, thank you for answering that.
Thank you. Thank you.
I enjoyed the column in both magazines. Kind of wish I were still doing it, but them's the breaks. And but at least I'm doing this every week.
Wow. Well, I'm glad to see magazines haven't died. I remember all the doom and gloom when the electronic platforms were taking off. It's a bit like people saying, oh, the book is going to be dead next year. Don't buy any. Well, who was wrong there?
That's been said for about 45 years now.
Yeah.
The death of the book. Yeah. Hasn't happened yet.
Right.
The people who get who get the print, which is generally people our age,
Yes.
but the people who get the print do not want anything but the print.
Well, it could be, and you mentioned age. In my case, it could be a result of age, but I'd rather be holding the damn thing in my hands. It's just, I find it easier to take the information in than looking at a screen. And there's a tactile stuff, of course. I don't know if that applies to younger people, though.
It does. It does. Most of my students like having at least a portion of the material in hand.
Great. Good heavens.
Hey, Jerry.
Hey, how you doing?
Hi, Jerry.
Hi. It's an interesting conversation you guys are having about the tactile in the real world versus the virtual world. It's always better for the real world to experience things directly, in my mind.
If you take an iPad to the beach, it usually doesn't turn out too well. That fancy,
True.
That's
Whereas,
right.
We
of course,
say
you can
that,
just-
but these days we require those screens for outreach, so we're taking them everywhere with us.
I suppose
True.
the best thing would be a combination of both, I guess. It's easier to
Well,
get the
it's-
sand out of a copy of astronomy than it is out of the iPad.
yes.
Right, but sometimes it's a path of least resistance. I mean, it's easier to reach for the phone to get almost anything than it is to try to look it up on a bookshelf sometimes.
Well, and of course, I mean, really, the majority of people in their teens, 20s, and 30s only read things on this,
Yeah.
and they don't all necessarily immediately know that about 90% of the most important information scientifically doesn't exist, but in old style libraries, So-
Excellent point. Yeah.
it's not like all research is on the internet, not by a long shot.
Yeah. Of course, Karim would be encountering that a lot, I'm assuming. It'll be worse in the humanities, in my experience.
It's definitely worse in the humanities. I embrace it. I have the students do digital resources for the course instead of a static textbook, but then I give them the static textbook access as complementary materials. And during labs, we have a component of digital labs, as well as some where they actually have to go out and take observations themselves, and even some now that are doing astrophotography processing. So we try to combine a little bit of what they're the most engaged in now, along with where they'll find most of the information in the archives. And I've had students actually say, sir, where can we go to look at these photographic plates of, Hubbell and Humason? We want to see these physically. And so I tell them, go visit Mount Wilson, go and see some of these archives that they have at the universities in the US and in the UK and, at the Royal Institute of Science, and go and actually see some of this.
That is cool that they even ask for that. And I have to admit, a glass plate has got a real presence
Yes.
as a thing. But yeah, that's anyway. So I guess the best thing again is to encourage people to use both. I guess your responsibility, Karim, or anyone. I mean, anyone in education applies to everyone on this. I suppose everyone at this session is the best you can do is point people to where the resources are, and it's up to them to make use of them.
It has to be a little bit more than just pointing them to where the resources are. You have to find a way for them to connect to the understanding of why those resources are important and the context why you could. So, for example, when we were talking exoplanet transits and when we were talking of some of the observations that were being made of the current universe, one of the things we mentioned was that people have gone back to those photographic plates and they've seen dips in the photometry. They've seen that there was evidence. They just didn't know that that's how they would find it or that's what they should be looking for. And so the idea that what was captured back then is there still to analyze and to understand. I mean, the Apollo moon rocks, we're still opening them up with new tools and studying and learning more about the moon, right? So there's a contextualization that has to be delivered in some way that engages the youth so that they understand why these resources are still important to pay attention to.
Well, that's a good lesson too in going forward with new technology. You go back to even the current data we have today, we'll go in 20 years and reanalyze it
And
with
Randall
new
is
tools and
watching.
find new things. I imagine quite a bit of stuff like that.
I think
But
that's
it
what-
also gives you a
Absolutely.
historical context on the way things were developed. That's the biggest thing for me, and the way technology is developed over the last 100 years or 200 years, is to really understand why it developed the way it did, and why we're where we're at right now. Why we're here.
And the current data is not just something that can be checked on a line in a book. Going to look up data on Ned or Sinbad is an art in what you select and how you use it. There are hundreds of bits of data that vary in quality all over. So it's a complicated thing to get the best information.
I mean, yeah, David's absolutely right. If you can bring it off,
The
to use
Milky
it
Way.
scientifically, I'll shut up.
Billions of stars, rising and setting over billions of worlds, including our own. In this vast expanse, how did our sun, the Earth, and the planets come to be? In recent decades, our understanding of the solar system's evolution has greatly improved, but deep questions remain. To answer those questions, astronomers are preparing to visit someplace very small. Asteroid Bennu. A lump of rock and organic material, the early building blocks of the solar system, of Earth, of us. Bennu is a time capsule, and its journey takes us way, way back, 4.5 billion years. The raw ingredients of Bennu and our solar system originated in a stellar nursery, a vast cloud of hydrogen, helium, and dust. Our own sun doesn't yet exist. Nearby are hot stars like this one, quickly burning up its fuel and destroying itself in a colossal explosion called a supernova. The explosion destabilizes our cloud, causing it to collapse. In the geologic blink of an eye, 100,000 years, gravity and angular momentum flatten the cloud into a swirling disk. In the center, where molecules crash together tightest, a protostar revs up to incredible pressures and temperatures. Deep within the disk, clumps of dust not much larger than a grain of wheat are flash heated into droplets of molten rock, called chondrules. The source of this heat remains a mystery. Chondrules are destined to become the building blocks of the solar system. Coaxed by gravity and turbulence, the chondrules clump. They grow into the first asteroids, into mountains, into planets. The asteroids are rubble piles of rock, metal, ice, and organics. This large asteroid is the parent body of Bennu, a protoplanet whose size we can only guess. Closer to the protostar, a planet begins to form. And then, dawn in the solar system. The protostar undergoes fusion and ignites, revealing our sun. But the solar system is far from finished. Jupiter most likely forms near its outer edge, but just 500 million years after the sun ignites, some believe that it slowly moves inward. Its massive gravity ripples the asteroid belt, disrupting countless asteroids and comets, flinging them toward the sun. They rain down on the inner planets, hammering and remelting large portions of their crust. Did these impacts also deliver organics and water, key ingredients for life? Back in the asteroid belt, Bennu's parent body is lucky. It survives this period of heavy bombardment. The solar system cools and calms. Jupiter and its many moons assume the orbits that we see today. Billions of years of quiet follow, more or less. Then 1 billion years ago, one theory suggests a collision shatters the protoplanet. Some of the debris loosely coalesces into a new, smaller body, Bennu. But Bennu will not stay in place. Dull, non-reflective, it slowly migrates toward the sun. Solar heating turns its warm side into a low-intensity thruster. Through millions of years, Bennu's orbit gradually tightens until it interacts with Saturn's gravity, altering its trajectory and hurling it into the inner solar system. Close encounters with Earth and Venus follow. Their gravitational tugs may have repeatedly stretched and reformed Bennu. turning it inside out and pulling off loose material. As a result, it has no satellites of its own. Until now. Today, NASA is sending a spacecraft called OSIRIS-REx to explore Bennu and retrieve a sample. Why? Bennu has survived its long journey and settled into a near-Earth orbit, bringing its secrets within our reach. Now it is ready to teach us more about the solar system's history, its formation, its evolution, and our own place among the stars.
Well, hello, everybody. Welcome to the 71st Global Star Party. I'm Scott Roberts with the Explore Alliance and Explore Scientific. We're really proud and happy to bring you this presentation. And the theme of the program is worlds, but worlds could take us anywhere. And that's what this Star Party is intended to do, is to spur on your imagination and to make you explore whether you're at your telescope right now or just sitting back watching this program. We want you to think about the universe that you live in and all of its imaginable and unimaginable incarnations. So if that doesn't sound real spacey, I don't know what does. So anyways, we have a great lineup of speakers. We will start off with David Levy. We have Carroll here, who's the president of the Astronomical League. Dave Eicher, editor-in-chief of Astronomy magazine, will be discussing Earth's universe of minerals. And I don't know if I'm going to pronounce this right, but I think it's pronounced Rhodochrosite. And is that right, David? Yeah.
You nailed it, Scott.
Yay! Okay. A beautiful mineral with crystalline structure that's actually quite rare. So that's very cool.
Your English teacher would be proud.
Karim Jaffer from the Royal Astronomical Society of the Montreal Center is with us today, and he will be talking about Astro Radio outreach and or reach out, I think is what it's called.
Yeah, reach out and touch space.
Space, right? All right,
Yep.
That's cool. And he'll be introducing Randall Rosenfeld of the Dorner Telescope Museum. Deepti Gautam from Nepal will be on later on, and then we'll take a break. We have Jerry Hubbell live from the Mark Slade Remote Observatory. César Brollo from Buenos Aires, live from Argentina. We've got Marcelo Souza will come on, and of course, I am going to come on with a short presentation about the power of stargazing. So it's a truncated presentation, what I normally give, which can somehow go on and on. And then we'll do a 10-minute break and then come to like a third session with our after party. So I'm glad you've all joined us. I want to turn this program over to David Levy, dear friend, comet discoverer, author, and friend of astronomers everywhere. David, it's all yours.
Well, thank you so much, Scotty. It is really a pleasure to be here today. And especially since we have a new presenter, a very special presenter named Randall Rosenfeld, who is here for the first time, and I hope he will be a regular on these future Global Star Parties. I first met Randall at the St. John's General Assembly of the Royal Astronomical Society of Canada. We were on the flight home from St. John's to Toronto, and then Randall would stay there, and I would continue on to Arizona. Anyway, we were talking about, the observing records that I had prepared over many, many years. And he suggested that I donate them to the Royal Astronomical Society of Canada. I could not do that because I'd already donated them to the Linda Hall Library in Kansas City. Not one to give up easily. Randall then suggested that the online version be donated to the Royal Astronomical Society, and that I did. And the Society has them all now. Randall has since become the first director of the new Dorner Telescope Museum, and I'm sure he will be talking about that a little bit later. As I go on into my observing and go out at night, as I will tonight, to look at the Taurid meteor shower, looking forward very, very much to that. Not very many meteors, but the ones we see are bright. And in fact, the brightest meteor I ever saw was a Taurid. Back when I was living at the other home in Corona de Tucson, it was so bright that the neighborhood dogs all started barking. It lit up the sky like day. It was really something. Will I see one like that tonight? I doubt it, but we'll see. My poem today is going to be from Tennyson, one of my favorite poets. I found out while I was doing research on Tennyson that he has a great-great-grandson who is living today. His name is Jonathan Tennyson, and I was able to meet him in London a few years ago. And I asked him about his, does he share the love of poetry that his great-great-grandfather had? And he said no. The poetry actually casted a long shadow through the Tennyson family. The minute I walked into his office, there was a framed picture on the wall that contained 2 stanzas from the memoriam. I looked at Jonathan, pointed at the poem, and Jonathan said, well, you can't want them all. It's part of the family. Anyway, my poem today is from Ulysses, another Tennyson poem. And I hope you'll enjoy it as you go out and observe the Taurids tonight. And as you think of all the worlds that are out there, which is our theme for today, and imagine the worlds from Earth-sized worlds, Jupiter-sized worlds, even to the tiny worlds of meteors. The lights begin to twinkle from the rocks. The long day wanes. The slow moon climbs. The deep moans round with many voices. Come, my friends, 'tis not too late to seek a newer world. Push off, and sitting well in order, smite the sounding furrows. For my purpose holds to sail beyond the sunset and the baths of all the western stars until I die. It may be that the gulfs will wash us down. It may be that we shall touch the happy isles and see the great Achilles whom we knew. Though much is taken, much abides. And though we are no longer, not now, that strength which in old days moved earth and heaven, that which we are, we are. One equal temper of heroic hearts, made weak by time and fate, but strong in will to strive, to seek, to find, and not to yield. Back to you, Scotty.
Thank you. Yeah, that's awesome. Beautiful, David. There's a comment from the audience. Actually, there was an earlier comment earlier in the week, and someone was asking me to ask you about Comet Leonard and what you might know about that comet, if you've been observing it, and what you think might happen. It's supposed to be supposedly a brightening or becoming a bright comet.
It is right. I'm allergic to comet.
Especially bright ones.
Yeah. Anyway, Comet Leonard I have not seen yet, but I'm looking forward to seeing it later in the year, in the late this month or next month, as it gets quite bright in the morning sky. It'll be nice to see a bright comet. It's supposed to be the brightest one since Neowise, and looking forward to seeing it at the end of the year. And that's about all I can tell you about it. But remember that comets do what they want. And you know my most famous quotation about comets and cats? It started out impromptu. I was being interviewed the day before the Shoemaker-Levy 9 impacts on Jupiter on NBC, the Today Show. And they asked me how I could describe comets. And I had gotten like 2 hours sleep that night, was very nervous, didn't know what to say. And I just said, on the slide, comets are like cats. They both have tails and they both do precisely what they want. And that quotation has lasted all these years. It was invented that day on the Today Show.
Wonderful.
David, I have a question. I was on the phone for a minute with Tyler, so I didn't get to hear everything you said. But did you mention that comets were seen as a harbinger of bad times?
Yes, I don't know. I didn't mention that, but you're absolutely right, Jerry. They were, and
not that the pandemic and Neowise and what was the other one? Pan-STARRS came along right before that. So
and the Hale Bob certainly led directly to the deaths of those 30 odd people at Heaven's Gate. But I believe that comets can have effects on people. And as proof of that, I offer myself. Comets have had a very profound effect on my life and how it has been led ever since I was an elementary school student. Started searching in high school in 1965. And I'm still doing that today. Thanks, Jimmy.
One last question, David. Minerva, the telescope in front of you, someone wanted to know more about this telescope.
Minerva is one of my very favorite telescopes. And this is not an image, this is the real telescope. And when I go out to the dark site that our club has, which I try to go once a month with my friend David Rossiter, I bring this telescope and use it. I've had it since May 1967. It's still one of my favorite telescopes. It is not quite optically as sharp as Narcissus, which is the Explorer Scientific Schmidt-Newtonian that I have, and that Randall may talk about later. But it has history, and that's why I use it.
Okay.
It is a 6-inch f4 Newtonian reflector. The tube has been changed multiple times, the mounting has been changed multiple times, but the optics are the original optics from 1967. It was made by a firm called the Optical Craftsman, and it arrived the day after I was almost expelled from the Royal Astronomical Society of Canada. The day after, a few hours later. And that's a story for another time.
Karim and I apologize.
Yes. If I had been around back then, I would have fought for you.
Me too.
Thanks.
I look as if I was around back then. I'm more or less innocent.
I have to say, when David was describing that, it occurred to me, you know, when you talk to car collectors and they have this old car, it's an antique, but then they talk about this part was replaced and this part was replaced, but it's still the original car. Right. So when David talks about his optical, I always feel like that, like he's telling us the history, but he also has kept track of every single piece that's been modified, but it's still the same scope.
Right.
Yeah, exactly. And I use it. I've not discovered any comets with this telescope. I've made independent discoveries of comets with this telescope, and I've seen a ton of comets with this telescope.
Wow, that's great. That's wonderful. Okay, we are going to go to Carroll Orge from the Astronomical League. The Astronomical League is the world's largest federation of astronomy clubs, over 300 clubs. I think around maybe over 20,000 members.
Just over 20 now, yes.
Just over 20 now. They're growing and growing fast, and they are global. You can become a member of the Astronomical League from any country through their membership at large program. So you'll want to get in touch with them at astroleague.org. But Carroll, it's a pleasure to have you on the program, and we are anxious to learn about the door prize questions. And later on in the program, you'll honor us by talking about the 75th anniversary of the Astronomical League.
It's
So
a very exciting year we're in, so looking forward to that. Thank you,
Yeah.
Scott, for the nice introduction. And David, I'm dying to hear about that other story one of these days, but as you say, that's for another time. So anyway, let's share my screen here. Let's jump right into the questions. Anytime we have door prizes won, we always like to have the proper precautions, particularly if it's an instrument that you're going to be looking at the sun, to make sure that we have the reminder that you're not to look at that without proper filtering if it's going through a telescope or on binoculars and so on. So that's something we always like to remind our members and other visitors tuning in. Now we'd like to go to the last star party and give the answers from the GSP for October 26, 2021. The first question, the snake eyes are found in what constellation? We had 4 choices. One was Scorpius, Serpens, Hydra, and Ursa Major. The correct answer was Scorpius. Second question from the last GSP, which of these famous stars is by far the largest? The Sun, Sirius, Antares, or Arcturus? And the correct answer is Antares, the red star. Antares. The final one, for almost 50 years, this dwarf planet in the asteroid belt was regarded as a primary planet. What is it? The correct answer is Sirius. And we had several people correctly answer the questions. Andrew Corkle, Josh Kovac, Rick Eubank, Norm Hughes, Israel Mataroso. He's been on this program several times. Cameron Gillis is always on this program, it seems, and James Hubbard, who's also been on a couple of times. And the winners for the month of October, and we select winners, preliminary winners each week, and then have a final drawing at the end of the month. And the winners of a special prize for October are Israel Mataroso, James Hubbard, and Dennis Walsh. So congratulations to all of you, and you'll be getting your prize very soon. And now let's look at the questions for tonight. And as with all of our GSP star parties, send your answers to secretary@astroleague.org. That's secretary@astroleague.org. Question number 1. Who described Saturn's rings as the ears of a teacup? Who described Saturn's rings as the ears of a teacup? Send your answers to secretary@astroleague.org. Question number 2. Vesta is which type of celestial body? Vesta is which type of celestial body? And the final one, what is the sun's outermost atmosphere called? What is the sun's outermost atmosphere called? And again, send your answers to secretary@astroleague.org. And as Scott was saying a few minutes ago, I'll be back a little bit later. We'll talk about the special celebration we have coming up in just a few days, technically, our 75th anniversary. Back to you, Scott.
Great. Thank you so much. There we go. Okay. All right. Well, that's fantastic, and really looking forward not only to hearing about the 75th anniversary event, but experiencing it. So it's a huge milestone in amateur astronomy, and something that you should all check out. So more about that later. Coming up next is Dave Eicher from Astronomy Magazine. Now, Dave not only describes the deepest depths of our universe in all of its amazing complexity, but he brings it on home with his collection of minerals and crystals, because it's all, of course, connected to the entire universe. And it's amazing what gets cooked up here in our own planet. And so, David, I'm going to turn it over to you, man.
Thank you, Scott. I'm going to do some more. We'll do some more planetary science tonight, if that's okay.
Tonight, okay.
Some more minerals. Let me start the show here, if I can.
Yes.
And are you seeing that okay?
Yes, it looks beautiful.
I've used Scott's.
I just love that specimen, by the way.
It's very nice. It's a piece of tanzanite, which is a silicate mineral called zoisite, and the fellows who discovered a lot of gemmy crystals of this type in Tanzania in the late 1950s and early 1960s, rather than calling it zoisite, they had the great marketing idea to call it tanzanite and start making jewelry out of it, and they made countless tens of millions of dollars from it. So there you go, tanzanite from Tanzania. But tonight I'd like to talk about a different mineral, but I'll talk a little bit about minerals and about a universe of order first, if I can, one of our themes for tonight. The universe is ordered. It's not ordered by plan, but it is ordered by physics. Thomas Jefferson famously said, "I believe in a divinely ordered universe." Isaac Newton, one of the great heroes, founders of modern science, if you will, said truth, among many other things. Truth is ever to be found in the simplicity and not in the multiplicity and confusion of things. Well, the universe is ordered not by supernatural design or by magic, as Richard Dawkins likes to say, but by the principles of physics. Minerals, in a very simple way, are how the universe likes to build planets, and they demonstrate that. Their atoms are assembled in precise ways, not by magical properties or supernaturalism, but by electrochemical attractions that are properties of these atoms. So they come together in a specific way when the chemicals are available in that way to make up a specific, what mineralogists call a crystal lattice. So we're seeing the way planets are built. And as we've talked about before with some other kinds of minerals, we have about 5,000 species of minerals on Earth. We went through a big event a little more than 2 billion years ago on our planet when a lot of free oxygen was suddenly available in the atmosphere. What does oxygen like to do? It likes to combine with things very, very easily and rapidly. That tripled the number of minerals that we have on our planet, from about 1,700 to about 5,000. So, but a lot of these would be because of, we know that the chemistry in the universe is uniform. We know that through spectroscopy everywhere we look. The properties of planets would change from, one end of the spectrum to another as far as temperatures and pressures and so on, but the chemistry would be the same. So these minerals give us a glimpse not only of our Earth and how it was built, but of other planets in the universe as well. Tonight, I'd like to talk a little bit about a favorite mineral of mine and of many, many collectors of minerals who enjoy planetary science, Rhodochrosite, which was thought to be just a kind of an ordinary thing. And then in the last 150 or 200 years, some really magnificent specimens of this mineral were discovered in a number of places, and it got to be a very popular mineral because of its color and crystal form. It's manganese carbonate. So it's a carbonate, which is a CO3 here, carbon and oxygen, with manganese attached as well. It can be pink, rose, red, strongly red colored yellowish gray, brown, or gray. It's a primary gangue mineral. That means it's not really inherently very valuable as an ore, but is pretty. It forms in moderate to low temperature hydrothermal veins. So these are hot chemical fluids that are rich in carbon and in manganese that form these crystals. It was named in 1813 by Johann Friedrich Ludwig Hausmann from the Greek word for rose, rhodochrosite. Hausmann has an interesting mineral named after him as well, Hausmannite. It's a member of the calcite group, these carbonate minerals. Calcite is a calcium carbonate. And it forms a series with calcite that's a very, very common mineral, and with siderite, which is an iron carbonate mineral. There are great localities for this mineral. The type locality, that is the first discovery where the first good specimens were found and it was analyzed and named, is in Romania. But there are great specimens that come from all sorts of places, including Colorado, Mexico, Argentina, and others. So I'll show, as I've been doing, just a few examples culled from my own humble collection, but not quite yet, to show you a few examples of these. First, though, here's the crystal structure of rhodochrosite. Rhodochrosite likes to make rhombohedrons, ideally, as far as its crystal, what mineralogists call its crystal habit, the shape of its crystals coming together. And here's a simplified diagram of one, and you can see that purple represents manganese, gray carbon, and red the oxygen atoms in this crystal diagram. So here's the famous American mine locality is a defunct silver mine that actually my father, John, I've mentioned him now and then, back in the 1920s and 30s, when he was first out in Colorado, it was called the Home Sweet Home Mine back then. And it was a defunct, used up, worthless silver mine near Alma, Colorado. And then someone in the late 1950s discovered a huge wall pocket of beautiful rhodochrosite in this mine, and it had a whole new second life, this mine. So this is a very famous locality now for rhodochrosite. Here you can see a few small quartz crystals as well, and you can see this rhombohedral shape here on this specimen. But it doesn't always form that way. There are what are called scalenohedral crystals as well, and this is a very intense cherry red color from the manganese atoms is what colors this mineral. And you can see this kind of crystal form comes from a variety of mines in the Kalahari manganese fields in South Africa, which is another important locality for this mineral. This is rhodochrosite with calcite, the white calcite here. You can see these kind of rosettes forming the crystal structure here. And this is from the type locality in Romania here, the original discovery of rhodochrosite. And you can see it ranges from that intense red to this is sort of a bubblegum pink, a lot of the specimens as well, depending on the concentration of the manganese contaminant, if you will.
Amazing. It looks very fragile.
It is, I haven't gotten into all the properties of all the minerals because I'm torturing you enough with all this time, but there's a lot that can be talked about with this. You're right though, Scott, it is a relatively soft mineral. So it's difficult to cut and use in jewelry because it is relatively soft. But it's a beautiful mineral to display. Here's another Colorado mine. This is called, not far from the Sweet Home, this is called the Sunnyside mine. And you can see the rhombohedrons of this sort of pinkish color here with a lot of quartz crystals on this one. This is a rhodochrosite. You can see these kind of balls or spheres of the mineral here with quartz and with some calcite as well, from a Greek locality. So this is just kind of showing you the same mineral can have a fairly big range of color and of crystal forms or habits. Here's a nice from Potosi, Mexico, example of the Mexican rhodochrosite as well, which is kind of a botryoidal, grape-like series of kind of grapes on a platter kind of shape of the crystals. This is a very famous American location that's very old, that predates the Sweet Home mine, the Emma mine in Butte, Montana. Butte, Montana is a huge, very old American mining district, and this was one of the early finds of rhodochrosite in the United States. This is a blade that's fairly large. It's maybe about 6 inches across or so, and very intense color and fairly thin. We're looking at it, but it's fairly thin if you were to rotate this 90 degrees. This is from a relatively recent Chinese find, the Wutong mine in China. Then we go back, here's another Romanian example that's a little bit different looking than the earlier one. Even from the same mine, the same locality, you can get looks from these different individual specimens that vary a good deal. This is a big one. This is about the size of one's head here, a big chunk, a big rock, rhodochrosite with pyrite. This is another old European locality in Bulgaria here, and you can see little cubes of pyrite on the rhodochrosite as well. Now this is interesting. This is from a very interesting and unique place called the Kerch Peninsula in the Ukraine. And what we're seeing here, there's back and forth with mineralogy, not only making planets, but with living things. Now, that I imagine most all of you know that your teeth, for example, which are the most dense things in your body, are made of hydroxyl apatite, a mineral. And this is a fossil shell that is something on the order of 5 to 3 million years old that lived and died, a bivalve, in this pit now that is in the Ukraine. And at some point, a couple million or more years ago, recrystallized part of its shell in the mineral rhodochrosite. So there's an exchange sometimes of minerals back and forth, of course, between mineral samples and living things as time goes on, and especially on very long time scales, which is kind of fascinating. This is a big plate. This is my nicest specimen. This is about almost a foot across. And it has really nice, these sort of cherry red rhombohedrons of Sweet Home rhodochrosite. This is a little bit tough to get now, a piece of this size from this mine. And it has a lot of quartz crystals. You can see the long, thin quartz, and then some other minerals too. Most importantly, this sort of dark gray, which is a sulfide mineral with antimony and silver and a few other elements in it called tetrahedrite. That's from the Sweet Home mine. And that's a nice one. That's a big plate there. And then I thought I'd show one interesting one. There's an Argentinian locality where a lot of rhodochrosite comes from that is cut and made into display things. It's relatively soft, as you said, Scott. But in this mine in Argentina, the Catamarca mine, there are these enormous stalactites that form that are made out of this banded rhodochrosite. And this is a cut slice that has been polished. You can see cut out of a stalactite, which is pretty interesting and has a pretty intense color. And if you go to the Tucson show or the Munich show or one of these gem shows, you can see lots of this stuff available. And it's pretty neat because it shows you the formation from these central intense rings of how the mineral crystallized as more of this hot fluid dumped more of these atoms onto the crystal, and it built outward there. So that shows you how planets are made. So that is my little show of rhodochrosite, a manganese carbonate mineral that's a beautiful pink or red mineral that is attractive for collectors because of its intense color. Scott, back to you.
Wow, thank you. Thank you. Beautiful. Beautiful. All right. Well, we will we will move on to Professor Karim Jaffer of John Abbott College, right?
Yep.
And the Royal Astronomical Society Montreal Center. And Karim is going to be talking about a radio program that he's involved with, and I believe another character named David Levy might be involved in it too. Is that right?
He's popping in for a visit, and we're gonna have some fun. I see he stepped away for a moment, but I'm hoping he's back by the time I get to that spot. I do want to mention, with this fantastic presentation that David Eicher has been doing, I have to admit I'm trying to find room on my shelves. I need to get some of these amazing minerals on display. I think I'm not alone in that. Am I, Scott?
All of us, I think, were fascinated with crystals and minerals in our youth, and hearing David explain them and really be the one that can take us down into the atomic level of these things, it really makes them fascinating.
I have only one warning, gentlemen, considering you good friends. Just like books, warning, these things multiply quickly, so be careful what one wishes for.
Books, telescopes,
exponentially, right?
Exactly. Yeah.
Mm-hmm. Yeah, and I think as my kids get older and need less space, I can just fill up that space with all of my stuff for my hobby, right? And eventually they'll come and take that as well. I know. At least that's the hope.
It's no sin whatsoever in my book to be a collector.
That's right.
Yeah.
Agreed. All right, I'll share my screen. I actually, when I saw this topic of worlds, the first thing that popped into my mind was actually exoplanets, because I have a group of students that are currently doing exoplanet transits for their projects. And last Wednesday, after Jenna had joined us for a Star Party previously, she did a late night session with my students on the remote telescope that the RASC runs in California. And we managed to get a couple of transits of known exoplanets. And then last night we were up with the telescope from 10 p.m. till midnight our time, programming it to do a test object of interest. So now we're actually going to see if we can confirm possible exoplanets. So I thought, you know what, I'm going to talk about exoplanets, and I'm going to bring in the whole Exoplanet Tourist Bureau from NASA, and we're going to have fun. But in the back of my mind, the word worlds was just resonating in a different way. And so I actually want to pay homage to Scott in a way for opening me up to worlds of astronomy outreach. And that's what I want to do tonight, is I want to tell you a little bit of what's opened up to me since my first exposure with Scott to a global audience. And so part of this is, a little bit of an homage. Part of it is also to share with the audience an amazing volunteer effort happening in the UK that I think we all could benefit from if people have an interest in having a little bit more astronomy in their lives. And I think there's nothing wrong with having a little bit more astronomy in your lives. I don't know if Scott has any more room in his schedule, but if he does, it would be great for him to also be one of our guests on the Reach Out and Touch Space panel.
I'd be honored. Sure.
Excellent. I'm going to follow up with you on that. That would be fantastic. And David Eicher's already had a couple of his assistant editors on, but maybe we can get him on. And Carroll and everyone I see in the chat, I know I'm going to pull in at some point over the next, hopefully, couple of years, because this is the one thing about what the pandemic has brought us in terms of opportunity, is I really hope that this doesn't go away. I hope that when we're back in person and we're back doing things live, we still keep some element of this collegiality and this collaboration that we have across regions. And not just across field, but across regions, because it really adds to all of our lives, I think, in a lot of ways. So I want to talk about all of that. But first, I always do a little check-in with my local centers. I want to tell you about a neat little initiative that my outreach colleague, Russell, has been doing. And he's been trying to put together a set of InReach for our club. And the next InReach that we've planned is actually citizen science. And so the first episode of Citizen Science is happening later this month. We're going to be discussing solar and aurora science. We're going to be discussing some Zooniverse projects that my students get to do. And we're going to be sharing a simple little experiment to measure the speed of light in your own home. Now, this sort of inReach, we're going to open it up to guests. So if you want to attend, if you're interested, email me, montrealrask@gmail.com, and I'll make sure to pass you the Zoom link closer to the date. It's 8 to 9 p.m. Eastern. At that point, it's going to be standard time because we're going to stop this daylight savings and we're going to go back to the standard time. And, you know, it's going to match up very nicely with a nice late night and a full moon. So other than going out and taking some pictures of the moon, the rest of the observing might be a little difficult. So we tend to do our clubhouses at that time. And this is going to be a fun little inReach outreach event. And we're going to start with solar and auroras because, as everybody's been noticing, the sun's getting much more active. And our friend Chris from Astronomy by the Bay, who we talked to last week, he posted auroral forecasts over the last couple of days. Now, unfortunately, this past weekend, when we were hoping to see aurorae, we had nothing but clouds and rain in Montreal and clouds and rain everywhere. And I actually was commenting, one of the New Brunswick astronomers put this beautiful star trail up. And I mentioned that, you know, I asked my students to draw what the northern horizon would look like between the horizon and the zenith if you just open up your camera for 2 hours. And this was one of their test questions. And, you know, a lot of them found the pole star in the right location. A lot of them showed the right size arc. So I know I'm doing something right. But one person wrote, after they drew this beautiful diagram of what they would see, they wrote in the comments, but if it was Montreal, it would just be gray. And so not only have I taught them well the science, I'm teaching them the reality of the practical considerations of astronomy. But because Chris shared this, we actually got some images of aurorae from other locations in Quebec that weren't clouded out. And last night at around 3 a.m, the aurora was just dancing in a lot of the northern skies. Now tonight, we're hoping for an even larger auroral show because the sun gave off this beautiful cannibalistic coronal mass ejection yesterday. And I know our friends in New Zealand got amazing aurorae 12 hours ago. So we're hoping to get some. And it's actually going to be clear in a little while. So I might go out tonight if I'm not too tired after all of this. But what I wanted to share with you a little bit tonight was this journey that I've gone on since joining the Global Star Parties. And the first Global Star Party that I actually did was hosting the International Astronomy Day back on May 15th. And that was supposed to be a 4-hour wonderful presentation and set of great stories from our local Montreal center and a couple of friends. And it became an 8-hour marathon, and we had a blast over those 8 hours. And one of the things that I did at that point is I actually reached out to a few colleagues that I had met over this Zoom year, and I invited them to join us for this International Astronomy Day. And one of the ones who joined us was Pete Williamson from the UK. And Pete talked to us a little bit about using remote telescopes. And the way I had met Pete was his article in Sky and Telescope about doing JunoCam processing and doing some citizen science with JunoCam. So when I started chatting with Pete a little bit more, he invited me to come and visit and understand a little bit of what he's been doing in the UK. He's a fellow of the Royal Astronomical Society over there, and he's the lead volunteer on this volunteer radio show radio network called Astro Radio. They run off of an internet platform, and they have listeners from all across the world. Most of their shows, including the panel show that I'm on, Reach Out and Touch Space, reaches sometimes 350,000 listeners live.
Wow.
It's incredible. We have people from Antarctic Research Station. We have people from Iran in the desert. We have people from Japan and China. We have people from Australia, North America, South America. And it's such a diverse audience. And while we're in the show, they're dropping emails to Pete, and he brings some of them in. And in this Astro Radio, one of the wonderful things is it's not just astronomy, but it's the connection between astronomy and pop culture. And Pete used to be a guitarist and bassist in bands. And so he brings in this musical perspective. And most of the participants, myself excluded, have a bit of a musical background. I leave the music to my kids. They're much better at it than I am. But if you look at their schedule over the span of a day, you have a little bit of astronomy, a little bit of music, a little bit of a combination of those. You have the BBC Eye on the Sky. You have a search for near-Earth objects, so talking a little bit about recent observations and things to know about. You have some shows that are solely focused on music. And the one that I'm involved in is Reach Out and Touch Space. And that is recorded every Monday and Thursday at about 3 p.m. Eastern Time, which is about 8 p.m. in the UK. Now, Reach Out and Touch Space is a panel show. And so I just wanted to share with you a little bit of what this has brought for me before I talk to you a little bit more about the show itself. And in meeting all of these individuals, the first thing they were all interested in is how can we collaborate? How can we do things together? So I invited some of them to come and give public talks to my center. So Steve Warbis from the Macclesfield Society in the UK, who is very close to an airport, he and I were chatting about light polluted skies because Montreal is awful when it comes to light pollution. So he gave an amazing talk on being able to do imaging in light polluted skies and things that you don't worry about when you're actually stuck in the city. So for example, and I know this is awful for astrophotographers to hear, but he suggested imaging in JPEG because if you're in a light polluted city, the RAW doesn't give you very much more. And so JPEG gives you a faster turnaround time. And so if you're trying to do star trails or if you're trying to actually layer a lot of images, just use JPEG. And that's what he uses. He showed us being able to find what should be a dark spot and calibrate your image accordingly. And it's one of the tricks that I showed my students when we were doing Andromeda pictures that were taken within the city. Then you have Mary McIntyre, and I'm going to talk to you more about Mary in a little bit, but she gave us this amazing talk at the end of July on making stunning star trails. And not only did she give us this incredible talk, but she then put together a resource PDF for all of the individuals who attended the talk, plus all of our center members. And this was amazing because these were things that we've listened to our own members who do some of this astronomy. You've met Kwa, who does, Deep Sky from Downtown, and you've met David Schumann, who does a lot of astronomy pictures for us. But what they brought was a different perspective because they've been working with different equipment. They have a different collaborative environment over there. And so a lot of the techniques that she brought forward, most of us have not been using. They also have this beautiful astronomy and music festival that they do every year. And this year it was virtual. So I actually got to join and I got to participate as a presenter, even though it was right 2 days before my courses started. So it's called Solar Sphere, and it's an astronomy and music festival. And normally it's held at this ranch outside of the cities in the UK. And you go there for the day. And, it's a lot like most of our star parties, except that they have a band on stage pretty much the entire time. So there's a combination of astronomy presentations and live music from astronomers. And so they're sharing not just their astronomy background, but also their pop culture and their artistic side. And then Pete, of course, since I met him through the JunoCam stuff, he did a workshop for training some of our outreach volunteers here in Canada to do processing of Mars pics from Perseverance. And so he taught us a few of the things that he uses for the Perseverance pictures as they come in real time. And it's neat to see now some of our local outreach people starting to set up workshops for winter on processing Mars pictures from Curiosity and Perseverance. But I told you I'd mentioned to you a little bit more about Mary. And the reason why I mentioned that is because Mary was just awarded the 2021 Sir Patrick Moore Prize from the British Astronomical Association. And that's for her outreach work. And I've actually shown you some of her outreach work in the past. We talked about the Meteor network the Meteor camera network that she runs in the UK that has been keeping an eye on a lot of these impacts and looking for fireballs and looking for meteorite impact. And I heard David say he's going to go out looking for meteors tonight. So that was a picture from 3 nights ago over the span of 4 hours. Those are how many different streaks they were able to catch, with magnitudes up to, I believe she said 9 that they were able to catch. So even the very, very faint ones, they were able to detect with her camera network. And then she's been doing a lot of amazing sketching. And I shared some of that with the Global Star Party audience a while back. But this last weekend, she got to do her first in-person sketching after a long time. And so some of these sketches are from youth, and some of these sketches are from adults who've never sketched before, and some are from amateur astronomers that have actually done this at the eyepiece before. And this is what's amazing about these worlds intersecting, is because we do sketching here in Montreal, we do meteor detecting here in Montreal, you do it in the US, people do it all over the world. And so when we actually start to chat together and share our stories and share our experiences, we all have different trips and approaches that we can share with each other. Another member of the panel, Andy Briggs, he did a talk at Solar Sphere on how to photograph a black hole. And I loved it. So I said, would you mind coming and talking to my class about this? And he said, absolutely. And so he's joining my class by Zoom in a couple of weeks to talk about how to photograph a black hole, that image that we did. And what's neat about this is he keeps updating this presentation as new research comes out from the original data files, plus the ones they've been adding. So this twist where you can actually start to see the magnetic field lines is something that he covers, and he talks about how reliably we know that this is actually the structure that we're seeing from the polarization of the light that was detected coming from this black hole in M87. So Reach Out and Touch Space, the show that I'm on, is a panel show. It brings in guests in different research areas or in amateur visual and photographic astronomy and other sciences that overlap in astronomy. We bring in individuals who make optical instruments, individuals who have inventions that they've put out on the market that we want to talk about. And during the show, the panel is animated and chatting and discussing. Some days we don't have guests and we just have a full chat show of talking about the most recent things in space. And it's intermixed with music being sent out on the radio station. And whenever the music is sent out, the panel gets to keep chatting. So we keep chatting while the music is being played to the listeners. And we have individuals from all across the UK, Europe, and now Canada join into this panel regularly. So the reason why I'm bringing this up to you today in specific is because they've given me the invitation for next week to be Montreal week, after this week was highlighting some of the UK astronomers. So this past Monday, we had Dr. Jenny Carter, who's the Caroline Herschel Prize Lecturer, and she's going to be giving the prize lecture on November 18th. But next week, we get to do a Montreal week. And a Montreal week starts with our favorite honorary Montreal president, David Levy. And so David's going to be coming on Reach Out and Touch Space on Monday, November 8th. And I have here a picture of when David gave the Townsend lecture for the Rask Montreal Center the most recent time. And he got his double star certificate, which was fantastic. And I also have a little image here of when David came up for a surprise visit about 2 years ago, pre-COVID. And he gave us this awesome little model of a telescope that had been gifted to a father at St. Mary's University, I believe, if I'm not mistaken. And this was one that we now have in our collection at our library at John Abbott College. And it's the library that we host for the Rask Montreal Center, the I.K. Williamson Library. I want to remind you, using these pictures, that Montreal is the real home of David Levy, David to his friends. And so as much as, he's got his place down there and, he's got all his friends down there, and we did try to kick him out once a long time ago, much to our chagrin, we're still the home of David Levy. So we can't have a Montreal week on any show without having David first.
That's great.
Thank you. Thanks, Karim. That's
Of course. And we're looking forward to the chat because we recently had been talking about Carolyn Shoemaker and Jean Shoemaker, and a lot of the members of the panel had met Carolyn in the past. And so they're really looking forward to talking to David and getting a little bit of his experiences and his history. And we all know what an amazing poet and how his literary background that David brings. And this is the sort of discussion that we end up having in this panel show often is the crossover between professional astronomy, amateur astronomy, and literary sciences and poetry. I mean, musicians are pretty much poets and lyricists themselves, right? Our second speaker next week, or our second guest next week, is Dr. Natalie Willett, and she's the outreach scientist for the James Webb Space Telescope. She's the coordinator of the Institute for Research on Exoplanets here in Montreal, And after David for the Townsend lecture, we actually had Natalie give the Townsend lecture a couple of years ago, and she gave a lecture on the James Webb Space Telescope. And that's going to be launching in a month and a half. And so we thought it was timely to bring her in to talk a little bit about James Webb Space Telescope. And I hope this doesn't embarrass her, but I had to share with you that, there's a certain personality that comes out to do outreach. And we all know this because we have this side of ourselves that's a little bit zany. So I wanted to share with you her awesome Halloween costume.
Oh, that's awesome.
I so
like
enjoyed this when I saw
stretchy
it.
pants and the and her her skirt there.
Yeah, and her James Webb telescope. I mean, I love it. She has, and we had a life-size model of the James Webb on display in Montreal a couple of years ago. And so she has this little pendant that actually is made with that same hexagonal design for the antennae for that. So we're really looking forward to having some Montreal people come in to reach out and touch space. And I wanted to invite, if anybody in our panel or in our audience has an interest in joining into this panel show and coming in as a guest, listen up, watch some of our shows. All of our shows are recorded on Mixcloud, and the links are available on the Astro Radio website. And join us, come in as a guest, and we would love to hear from you. But one of the things I will tell you, and I'll warn you, and I've warned David about this, one of the first questions we're going to ask is, what are your musical tastes? And they can be as eclectic as you want. We're not gonna ostracize you for eclectic taste, or I do have to admit they tease me a little bit for the country that I listen to and the bluegrass that I listen to, because in the UK that's not very popular and that's not something that they can actually connect with. But there's some Beatles and some nice techno in my background, some nice hard rock, so they still accept me. So if you're going to come in as a guest, make sure to know what your musical preferences are, because we're going to ask you and we're going to share it with the audience. So that's a little bit of what Reach Out and Touch Space is all about. And so I wanted to share that with you. And I want to, again, thank Scott, because if it hadn't been for the GSP 45, I don't know that I would have entered into this whole global environment for outreach and made all the connections that I've made. Being able to all of a sudden, start messaging Maxi and messaging César and, reaching out to New Zealand and doing an event with New Zealand. These are things that a year ago wouldn't have been fathomable for us. And you've made a lot of this accessible. So I really want to thank you for that.
I'm very happy to have played a tiny role in that, but it really is your creativity, Karim, your enthusiasm, your passion, your knowledge. It's very contagious. I said it before and I'll say it again. I wish that, if I'd gone to school to learn astronomy, I wish I could have learned it from you. So I think you're fantastic and a true treasure in the astronomy outreach community. So thank you.
I appreciate that. And I love being a part of the GSPs. This makes my week often. It's hard these days getting through the week sometimes. And the GSPs is something that keeps driving me forward. That, Reach Out and Touch Space. And then, of course, the interaction with the students. Those things just keep you going.
Absolutely.
Now, as you know from the last couple of weeks, Scott invited me to bring in a couple of the RASC members from Canada to join the GSPs and tell us a little bit about their own adventures and the things they've been doing. And so a couple of weeks ago, we had Jenna Hines, who was the outreach coordinator for RASC National Office. Last week, we had Chris Kerwin, who is the head of Astronomy by the Bay and an amazing outreach person. And tonight, I have something really unique to share with the GSP audience. And I was very happy when Randall accepted my invitation to come in. And David was saying, how amazing it is to have Randall here. And I'm hoping that he will join us again periodically because he is just a wealth of knowledge. Now, Randall has been a part of the RASC for a long time. He had been a member of the Halifax Center and the Toronto Center, I believe, in the past. But a while back, he actually became an unattached member and started working at the national level. And his involvement and his exposure to all the centers has just skyrocketed. And I first met Randall a bunch of years back as the archivist for the RASC. And he was giving a talk on some of the history of the RASC at the 150th anniversary celebration when the society turned 150 years old, and Montreal had just turned 100 years old. And so he and I were having this conversation about kind of the contextualization of the history in modern astronomy. And we continued those conversations at different times. At this past GA, he gave a talk about Mars observations over the century plus. And so he was pulling out journals and observational sketches of Mars coming from, I believe, the late 1800s, which was incredible. And we've had conversations about, ancient astronomy and bringing in some of the Arab astronomy. And we've had all of these discussions. And in this position as archivist, I just want to share with you this quote from one of the former RASC presidents. Whatever Randall undertakes, he does so with thoughtfulness, thoroughness, good humor, and modesty. And Randall has run committees for us. He's been part of the RASC. And now he's taken on an even greater challenge. He is starting the Dorner Telescope Museum to basically give a way to share with the public the history of telescopes and astronomy in Canada. So Randall, I'll turn it over to you.
Well, thanks, Karim. And I want to thank you for the invitation. I want to thank you for twisting Scott's arm to allow this, and Scott for being tolerant enough to put up with me for a bit. So what I'm going to do tonight is introduce your audience to the Dorner Telescope Museum, as Karim has said. And to do that, I'm going to go to share screen and hope that I don't cause a power outage. Oh, look at that. And I'm going to ask you, when I finally get this up and running, can you actually see?
Yes.
Oh, good heavens, it's working.
Yes, it is working.
You might want to take him. There you go. Perfect.
How remarkable. So, Dorner Telescope Museum of the Royal Astronomical Society of Canada, and its logo is in the bottom there. Well, it's not its logo, it's its motto, which is to tell the story of the telescope in Canada. People, instruments, and heavens, seems to be a squirrel there. Oh, and Isaac Newton. Well, we'll ignore them. Marginal characters. So I'm going to start.
That's hysterical, Randall. That was awesome.
The origins. It's one of these. I think it's a computer bug. If the animals show up, if I ignore them, it won't encourage them. With any luck, they won't show up again tonight. So DTM origins, and DTM is short for Dorner Telescope Museum. So in the beginning, oh, sorry, that's the wrong image. Let's get rid of that. Ah, that's better. So in the beginning, and the beginning, as far as this goes, is the spring of 2019. Mr. Rudolf Dorner, and there he is with one of his telescopes. He's a longtime amateur with a love of visual observing, and he found himself in a circumstance when his mind turned to possible legacy projects. He had an affinity for telescopes, or I should rephrase that. Observing and telescopes were integral to his well-being and happiness. So why not turn that joy in these portals to the universe into something more lasting to enrich others? Well, Rudolf would provide funds to the RASC to turn this aspiration into a reality. I'm going to move one thing here. So the Dorner Telescope Museum, it would be, for the RASC, would be devoted to telling the story of the telescope in Canada. That's straight from its origins in the 17th century up to the present, to the instruments, the makers, and the users, and that's us. But that wasn't all. This museum would not starve its telescopes of starlight. It would find ways to dissolve the glass standing between the viewer and the people in the museum whenever possible, allowing the viewers or the museum goers to be more than onlookers of the sleeping artifacts. And the DTM would find the lost stories of forgotten instruments, makers, and users. And so early 2019, I get this phone call. Would I be interested in planning a telescope museum? And this was from someone in the RASC. And I said, sure, why not? And I secretly said to myself in the thought bubble, yeah, as if that's going to happen. I get contacted the next day that the donor wants to meet me. So obviously it seemed more serious at the time. So sure, I'll go along and give the fruits of my advice, or whatever they're worth. I carefully explained. I met Rudolf. Carefully explained to him why I would not be the person to, get this off the ground, to direct it. And he didn't listen to any of my advice, so I ended up as a director. So, the nature of the Dorner Telescope Museum. The Dorner Telescope Museum would concentrate on the Canadian story because much of that story is not well known, even to Canadian amateur telescope makers and historians of astronomy in Canada. And of course, it's in Canada. The emphasis would be squarely on astronomical telescopes and associated equipment, or optics not necessarily intended for astronomical use, but frequently put to that use by amateurs. While the telescopes don't have to be of Canadian manufacture to be included in the museum, they merely have to have been used by those with Canadian connections. And via that course, the Canadian story is not just a Canadian story. It includes, for instance, Americans. Canadian amateur telescope makers have been involved with stellarphane going way back. And there's a case where Russell W. Porter received advice when he started as a telescope maker from a RASC member in Toronto. And before Porter, there's Uncle John Brashear, a much beloved, fantastic professional telescope maker, late 19th century, beginning of the 20th century. He started out as an amateur, as a millwright, and became one of the top telescope makers in the world. And he's a wonderful person. If you're interested in him, you can still get his autobiography. Anyways, he was an active member of the RASC. And he'd often summer in a cottage in Ontario. And the founding president of the Antique Telescope Society thinks that the Brashear, which was bought for the Dorner Telescope Museum, actually is the one that John Brashear had in his cottage. I'm not so sure about that, but that's a cool story. So, to return to this text, the DTM would do both research in the telescope history and active education and public outreach. And done at their best, they go together. So for the former projects, that's the research stuff, there'd be things like the experimental archaeology of astronomy would be conducted with either surviving equipment or close reproductions. And the histories gathered pursuing this would be published. As for the education and public outreach, it would be as simple as taking some of the historical instruments or the reproductions and showing up at star parties to allow amateur astronomers today to, in a way, step back into the past and see what Galileo would have seen looking through one of his telescopes, or Isaac Newton, or Christian Huygens, or Charles Messier, which is sort of a cool thing. And of course, telling a good story is going to be central to all of the activities of the Dorner Telescope Museum. Narrative rules. Oh, and go up. As David and Karim could attest, it's quite common to find in Canada, in the wilds of Canada, beavers, like here, holding Galilean telescopes. I don't know if that happens in your countries. So, artifacts. Oh, they're back, I see. Well, we'll ignore them. We seem to be having a dispute. So here's a few of the artifacts we have. And some of you may be wondering, what is this doing in Toronto? This belongs in Florence. This is in Florence. This is this is a copy then. This is a copy by a Quebec member of the RASC named Réal Manceau, who also has stellarphane connections. And this is his reproduction of the display from the 17th century of two of Galileo's telescopes put into, it's almost like an equivalent, an astronomical equivalent it's a secular ossuary or reliquary of Galileo. This is done in 1677. And in the middle there, so on the right, is a cracked lens. And Réal has even reproduced the crack you can see in the original Florence. And that is reputed to be the lens from one of the telescopes that Galileo used to do his epochal observations, which he published in Sidereus Nuncius in 1609, which is a sort of a cool thing to have. This is an iconic artifact of the history of astronomy and telescope making. We're going to have this copy in our museum. Well, it is in our museum. And that allows, this is a telescope. This is an artifact, which is like a bridge. It's a bridge back to Galileo in the beginning of the astronomical telescope, and it's a bridge to a modern Quebec Canadian amateur telescope maker. That's sort of cool.
Very cool.
Another one, Isaac Newton. You've all seen this. You all know what this is, except this is not the one in the collections of the Royal Society in London. This is also a copy by Réal, and it's a very close copy of the surviving telescope by Isaac Newton. To speak more accurately, it's the earliest surviving instrument attributed to Newton. It's actually his third telescope, and he did it in cooperation with his friend Wilkins, I think is his name. And it probably dates from 1677. It's quite small, and it's got its optics, and it sort of works, which is very cool.
And 2 years ago, Randall actually brought that object to our RASC Montreal Center library night and shared it to so that everybody could take a look at it and actually come and see it. And that's where this outreach idea of having things in person and being able to see these instruments is just so unique.
The old instruments, well, I'll give you an example of this. I'm going to go off script, who cares? I'm doing that anyways. Think back to 2012, the last transit of Venus any of us are going to see. There was an event at a large stadium in Toronto, and it was run by the Department of Astronomy and Astrophysics at the University of Toronto. They had a bunch of modern telescopes. They also had a late Georgian Gregorian reflector from about 1800. Still has its speculum mirrors, speculum optics. The astonishing thing about that is that the brass and speculum metal instrument had a longer lineup outside it than the modern instruments. Because there's this sort of, I don't know what to call it, a charism, an aura about these old portals onto the universe. And when they're associated with someone, a famous name, even more so. David Eicher, I think several years back, published, well, both David Eicher and David Levy are involved with this. Clyde Tombaug's 16-inch survives. Apparently, I've never looked through it. I've never even been there. I think it's in New Mexico. I'm not sure. I should go back and read the article David published. It's in working shape, and it's there for, I believe, amateur use. And because it's associated with Clyde Tombaugh, it gains in its stature as an object. And that fact that you could even look through it is amazing. This could be said for the reconstructed Leviathan of Parsonstown, I suppose, Lord Ross. So what you got here on the screen in front of you is a Roland Brashear grating. So I mentioned John Brashear. This was produced by his company, 1895. And these gratings are amazing. The physicist at, I think it was at John Hopkins, I'm not sure, University, Henry Roland, is an amazing character. And I'm interested in scientific portraits. There's a portrait of Roland by, I think, Thomas Eakins, a great American artist of the 19th century. And it's one of the best portraits of a scientist from that period. It's amazing. The whole border of the portrait's got scientific equations relevant to Roland's work. And it shows Roland there, beautifully portrayed. And in the background is one of the ruling engines he invented. And that very carefully, very precisely puts those lines into the substrate, which breaks up, refracts the light, so you get the spectrum. And to have to see one of these things live, as you change the angle in which you view it, or you change the angle in which the light strikes the surface, you get this shimmering effect. It's really quite an amazing thing. And this is one of the originals. Okay, so Uncle John gave us one of these in 1899. At the end, he came up to lecture at the RASC. He surprised everyone by giving them one of these gratings. Well, unfortunately, perhaps in the 1920s, 1930s, the artifact developed legs and walked away. If you're not careful, this happens. We were given another grating, and the same thing happened to it. Now, to quote Oscar Wilde, to lose one grating is a tragedy. To lose two gratings, it looks like carelessness. But fortunately, thanks to Bart Freed of the Antique Telescope Society, we now have one to replace the ones we lost, which is this one, which I'm really grateful for. Finally, I come to a modern artifact. This is an artifact associated with two people at the Star Party tonight. Scott Roberts, who I believe had the brilliant idea of making these, and David Levy. You can see there's his signature there. Apparently, these are really sharp instruments, and I am overjoyed to be getting one of these for the museum. But we're not just getting one of these for the museum. I mean, that would have been fantastic, because even though it's American-made, and the two principals are American citizens, there's still a strong Canadian connection, because one of those American citizens started out up north, David Levy. And I think David has, foolishly otherwise, offered to give us his actual copy, the David Levy Comet Hunter. That to me is really cool.
Wonderful.
It's actually a brilliant design. Well, I won't go on about it.
That is a collaboration between David and I. So we had thought about for a long time about what would make a perfect beginning telescope that would take you beyond a beginner stage, something that could be visual, something could be used for deep sky planets, and be used for astrophotography. So that resulted in that particular telescope.
Oh, nice, Scott. Even the detail, you've got 2 places to put the finder. So depending on what you're doing, and that's just brilliant. Anyways, I won't go on about it. And I like Max. I don't know why, but I do. So I saved the best for the last. And it's this. When I gave the first formal lecture about the Dorner Telescope Museum, that was at Sunspot, New Mexico at the Solar Observatory there. This is for the Antique Telescope Society. So I talked about the museum, and I was talking about all the stuff we don't know about the history of the telescope in Canada, the instruments, the occasions they were used, the people who made them, where they came from, all that stuff. What survives, what doesn't survive. And I say, well, one of the main questions is when, where, and what was the first telescope used for astronomy in Canada? Do we even know this? Turns out it was in 1646. It was that early. That's 4 years after Galileo dies. It was done by a Jesuit. So one of the ancestors of Brother Guy, the Vatican, done by a Jesuit at St. Marie among the Hurons. He's observing a lunar eclipse. And so this is a drawing I did, a sort of reconstruction of it. And what I did is I put in the sort of telescope he might have used. Right. So this is about 1650. And I gave it a mounting, the same sort of mounting that Hevelius in his Cylindrographia of, I think it's 1647, would have had for his telescope. Well, what I wondered was, all right, we know about this. It's the first attested use of a telescope for astronomy in Canada. Bressani, and Father Bressani was a Jesuit, did the observations. He sent them to Athanasius Kircher in Rome at the Collegio Romanum. Kircher, called by one of his modern biographers the last man to know everything. Well, you shouldn't say that sort of thing because there have been lots of polymaths in the 17th century and even later, but he was a learned man. He sent the letter from Father Bressani to Giovanni Riccioli, who was the publisher of a great astronomy textbook in the middle of the 17th century, the Almagestum Novum. It's a fantastic book. Chris Graney, also the Vatican, has written about it. And Father Riccioli reproduced these observations done by Father Bressani in Canada and talked about their high quality. And the high quality, the reliability of the observer. Oops, get rid of that for a minute. There we go. Pierre Gassendi also reproduced the observations in one of his publications. And what Gassendi said was that Father Bressani in Canada used an exceptional refractor. This is 1646. That's quite early. But what that means is, I hate to use this term, so think of this in a colonial context, not from a First Nation standpoint, but from a colonial context in the middle of nowhere in Canada, or what would become Canada. A research quality mid-17th century telescope is being used to harvest astronomical data and astronomical quality data. And that to me is amazing. So I said to myself, we've got to get a copy. We've got to get this instrument for the museum. Well, that's not going to happen because the instrument doesn't survive. So I thought the next best thing is to get a full working reconstruction made as close as we can, as close as what we think it was, using the techniques we know would have been used at the time. So I asked Roger Saragioli at the Stewart Observatory Mirror Lab. He's one of the people who's worked on the Giant Magellan Telescope mirrors. And Roger has experimented with 17th century optical techniques. Roger, is it possible to have the lenses made for this? Before I got very far, Roger said, yeah, I've already made 2 sets of these, and I'd like to donate one to you. I'm going to ask my friend Walter Stefani in Germany whether he'd donate you a set. So Roger contacted Walter. Walter said, yes, not only will I donate the optics, I'm going to make you the OTA and the stand. according to 17th century models, using as close as possible 17th century techniques. We do, as far as we can know. And I'm going to also involve a museum technologist, Dr. Arne Payson, to help. We're not going to charge you anything for this. You just pay for the materials and the shipping. And this is the thing I suppose I'm most excited about. And it got me to thinking, and here's some pictures. So that's the OTA, it's finished. It's fairly long, as you can imagine. It's a singlet objective. There it is taken apart. And there's your close-up. So Walter did the OTA. This is the lens cell. It's turned out of hardwood, and there's one of the lens elements there. And that's sort of cool. And this is the cell for the objective. It's in there, but you can't see it. And what else we got? Here we go. So it's on the left. We've got the image from Hevelius's Sonographia, which we're using, which Walter and Arne are using. That's the blueprints that Walter came up with for building the Dorner Telescope Museum copy. And there's Arne in his workshop in North Germany, producing the stand and the mount. I'm really grateful to these guys for doing this. That's telescope,
just incredible.
They can take this thing to the Montreal Center, can take this to star parties, wherever. So what I'm hoping, and that's the end of that, so I'll get rid of share screen. How do I do that? Stop share. There we go. So what I'm hoping is to invite anyone listening to this who happens to be in the area. So we have a place for the museum. It's in the cultural hub of Toronto. It's in a renovated building, renovated historic building, which I really like. 45 College Street. So when the museum opens, you'll be welcome. If you want a tour before then, that can probably be arranged. And thank you for your time.
All right. That's awesome. Wonderful.
It's so exciting. I can't wait for this to be open and available. And it's right in the heart of Toronto, near the university there, where the Canadian Institute for Theoretical Astrophysics is. And it's going to be incredible.
It's also very, it's a big honor that one of our telescopes will actually be in that museum.
It's good of you to say that, Scott. Gee.
Yeah, that's wonderful. That is wonderful. So thank you for even considering it. And when I get back,
are you kidding? There was
definitely-
no question about good heavens. I'm grateful, lucky, and to have it for the museum, and I can't believe we're getting it.
Yeah, it's wonderful. It is.
Of course, I gotta be nice to David until it shows up.
Until he shows up. That's wonderful. So the museum is open throughout the week, or
it's actually not. It's not open yet. We haven't even
open yet. Okay,
it's not even. So I'm gonna. I could be optimistic and say I would like to have it. I'd like to have enough of it open and running so that visitors can actually come by the time of the next RASC General Assembly. But I suspect that's going to be optimistic, and I'd say maybe a year from now.
Okay.
But if anyone wants a tour of stuff, that's easy enough to do. A tour of stuff before then.
And
That's
the nice
easy.
part is going to be making all of these instruments accessible and telling the story of astronomy in Canada.
I should ask, there's one more thing. I'm probably taking up too much time, but Rudolph didn't die, which is really cool. I went observing with him at a star party at the beginning of October. He's still battling with the diseases he's contracted, but he's still alive and kicking and using his telescopes, which I find very gratifying. I don't want him to go away. He's too much fun.
Right.
The other thing I was going to mention,
Agreed.
I'm going to put a plug in for another telescope museum. There's a fantastic collection of antique telescopes in New Mexico. It's run by John Briggs. Some of you may know John. John's a lot of fun. He's immensely knowledgeable.
He's a VIP for us.
Yeah.
Okay, so he's probably talked about the Lyceum in Magdalena. Right, fantastic dark skies. John's got way more stuff than we have. John's got, I don't know. John's like one of these. He must have this internal dynamo when he goes to some place, and all the telescopes in the city just suddenly attach to him. I have a caricature of John running off with a Palomar. John's got a bit. He's got one of the bits of Palomar that Russell W. Porter sketched. He's actually got the equipment in his museum. And that to me is one of the coolest things I can think of. Well, I mean, he's got stuff which has been important, signally important for the growth of astrophysics in the States, and stories to go along with it. So yeah, so I don't know to talk about him. This is cool.
Yeah. One of the most incredible moments for me in terms of this instrumentation was actually getting to be there when they restarted using the spectrohelioscope at Stellafane a couple of years ago.
Yeah. That's such a brilliant, so that's George W. Hale. And that's one of those amazing things that was co-invented by someone at the same time, and I believe there was no cross-influence, but they both came up with the idea of the spectroheliograph. There's a French astrophysicist based at the Astrophysical Observatory at Meudon, which is also a wonderful place to visit if you can get in. They've got their original spectroheliograph. It's been upgraded. I believe it's the original. It's been upgraded over the decades. Yeah, but Karim is right. It's just, the one at Stellafane, I think, was built from one of the kits that was made early on. I think it was in California. Yep. And they finally got it running. Matt Considine and some of the other guys there. And it's really, in a way, okay, so it's impossible to really step back in time. You cannot forget the Hubbell images you've seen. But it's still worthwhile to try. It's still worthwhile to try, because I think through doing that experience, through observing through the eyepieces they may have used, through sitting where they made the observations, through looking through the instruments, you can experience something. This is, I guess, an emotional thing, partly emotional. You can experience something or tell yourself you're experiencing something with the original observers. The other thing is you get a hands-on experience. So when you do talk about their achievements in astronomy, you're not making up stuff because you've had something of that experience, but there's something else. As a research part of this, it's a bit like experimental archaeology. It'll inform you of what it was like just through trying to handle the equipment to make observations back then. And that has a direct bearing on your interpreting the old observations.
Absolutely. I think Scott will remember Connell Richards, one of the youth members who presents. He was talking about the Leviathan and going to see that in person.
Oh, that's so cool. At Burr Castle.
Yeah.
I've not been there. I'll tell you a story. The engineer who directed the restoration of that, I forget it, his first name is Michael. I forget his name. He was the original flute player in the Chieftains. It means It means, as well as being a top-notch, speaking of polymaths, as well as being a top-notch engineer in Ireland, he's also a virtuoso traditional Irish flute player.
That sounds like somebody I need to get for Astro Radio.
Do it if you can. He's getting on now. I still, as far as I know, still got all his marbles. He's a good friend of Sarah Schechner, who's a curator, David Whitling curator of the Harvard collection of scientific instruments, and her husband, Ken Loney, is an amazing. Ken Loney worked with Baker, who did the Baker Nunn camera.
Okay.
Anyway, I should shut up. I'm taking up too much time.
Oh, that's great.
It's very interesting.
Well, I would like to add my thanks to you, Randall. I really did enjoy that. And I wanted to add that you are able to speak Latin better than I can speak English.
I was afraid you were going to raise that. Look, I didn't mean to. I stubbed my toe and I just started swearing. It was Latin. Like, I'm sorry about that. The cats ran away. I'll tell you people's story. So David mentioned the first time we met. What he didn't tell you, and this has probably happened to some of you, is that he's very good. I'd hate to play poker with David. So we're on the plane, and he says to me with a straight face, "Oh, I forgot my camera." And he rummages around. What am I going to do? I was like, "Oh my God, I'm here. I'm sitting beside this famous astronomer. What am I going to do?" I guess so. I started to get up. I go, I'll have to speak to a stewardess. What am I going to do? And David pulls my arm. He said, "Oh, just kidding." That's what I remember from the first time we met.
Was this gentleman that was involved with the Leviathan restoration, was his name Richard Freeman?
No.
No. Okay.
Michael, no, I'm going to mangle his name. I just can't remember it. But he's the original flute player in the Chieftains.
Interesting.
I mean, there are numerous people with that restoration. I half wish they decided to make with all the problems, I still have wished they decided to cast a giant specular mirror just to see what it would be like observing through that.
Yeah, from what I understand, they had 7 mirrors for the Leviathan.
You could do them in circulation,
And
exactly.
They're being installed for just a short time, maybe a week or two. Okay, because it's speculum, and the mirror is oxidizing as soon as they finish polishing it, right? And so they have to take it back out, repolish, to get a shine on it. Okay. And
Let's
then,
just put it this way, Scott. Aren't you glad you're selling reflectors now and not 150 years ago?
so hard. And then you look at guys like Christian Huygens, who had the aerial refractors.
Yeah.
These refractors were, I don't know, 20, 30 feet long or something.
Some of them were 150 feet, 210 feet long.
Oh my God.
Yeah.
The two Huygens brothers built them at that sort of
Yeah, and they're just
focal length.
an eyepiece at the objective lens with the.
Actually, the
Rover.
depth of field was so great that you could have 3 or 4 people, each holding an eyepiece, looking through at the same time, which is sort of cool.
Wow.
I'll say one thing. Remember, though, Christian Huygens and Cassini so Giovanni Battista Cassini, made those discoveries using those instruments.
Yep.
And according to Roger Serragioli, the good ones are diffraction limited. Now, there's a planetary scientist, David might know him. Both Davids might know him. I don't know, named Alan Binder. He might be in the Tucson area. I'm not sure. Anyways, so he retired.
Yes.
Cool. He retired and he made 2 of those medium focal length mid-17th century refractors. And he observed the planets. He observed, that's it, Karim, you got it. And
The restoration was by Michael Turvidi.
yeah, that's right.
Okay.
And so Alan Binder, and he also did double star observations. And I think even Alan was surprised. First of all, the amount of detail you could see on the planets, and also the double star separation, how close you could actually observe these things. And the other thing is a certain person of my acquaintance, whom shall not be named, was at a certain museum in England, which shall not be named. He was there with his wife, and there was only one guard on duty at the time. And this museum had one of Herschel's 7-foot reflectors. He posted his wife, that's the second floor. Guard wasn't around, posted his wife at the door, and he put his hands on the instrument and started to play with it.
Oh.
And what he found out is that, now we look at those Herschel 7-foot instruments, they look ungainly. It would be a pain to try to get going in azimuth, or he found no stiction. They stayed where you put them.
Yep.
They were precise. The action was smooth after over 200 years. So I think the lesson here is, and this goes back to what I was talking with Scott about before we formally started, that interesting instrument on his desk, the smallest instrument there, which some people call a junk scope, except in Scott's hands it wasn't. And his optics were good enough that it wasn't. You can't judge the book by its cover. You actually got to use it. People have done this with Charles Messier. Most of the people who talk about, well, Messier couldn't see the double cluster because his instrument wasn't good enough. He probably couldn't see the double. He probably didn't include it in his lists for other reasons, not the instrumental ones. So you got to be careful in blaming the instrument.
The Herschel House is it's accessible, and one of the educators there, Simon Holbech, is one of our panelists in ROTS, and he
nice.
often talks about the programs there and how amazing they are, and like just being able to give a talk in the room where
Isn't that incredible? Isn't that
nuts?
Yeah, and being able to go to the workshop and see there's one of the other thing with speculum, of course, is got this molten metal. You're pouring this in your garage, in effect. Accidents can and did happen. Well, there was a famous one at Herschel's where the mold cracked and the hot molten metal came flowing out. They had to run for their lives. It cracked. Yeah. I mean, you can go out there now and see the cracks in the tiles. I think it caused them to sort of explode, and the cracks are still there. So yeah, that's a cool place. And they've got a beautiful reproduction of one of the 7-foot reflectors.
Okay.
When they were molding those or pouring that metal, do you think they ever thought about spin casting the metal? like we do today?
Jerry, that's a great question. I have found references. I don't know if they go back to the 18th century, but there are, I believe, 19th century speculations about, because people saw how Mercury behaved in that situation. Mercury on a turntable, and there's some modern telescopes they experimented with that with, and so I think it goes at least back to the 19th century. The idea, at least the idea, we should try spin casting. It would give us the general shape we want. So yeah, absolutely.
Great, wonderful. Randall, thank you so much.
Oh, my pleasure. Thank you for putting up with me.
Welcome to come back on to Global Star Party at any time we run this program.
It's good of you to say that.
Thank you very much. Great.
I might not be able to stay very long. I've got to do some medical stuff, but whatever.
Sure.
Happens when you get old. But thank you again.
Thanks very much. Thank you. That was awesome. Thank you, Karim, for suggesting Mr. Rosenfeld for coming on to our program. It was
my pleasure.
Wonderful. And we have had a little bit of change up in the schedule. And it appears that Deepti may have run into some internet problems. And so, she comes on later in the program, then we can have her on. But for now, we'll take like a 10-minute break. We will have Jerry Hubbell from the Mark Slade Remote Observatory come on. And then we've got Carroll Orge from the Astronomical League, who will be talking about the 75th Astronomical League anniversary. So be back in 10. We'll be right back.
And by the way, I just want to mention, I was looking up Michael Turbiddy, and he was the director of Rob Roy, the movie. I had no idea.
Is it the same guy?
Same guy. He was the chief flutist for the Chieftains. He was a director of 3 movies, including Rob Roy. And he was an amateur astronomer and engineer who decided to restore the Leviathan and the Burkastle facilities.
Yeah, you're better informed than I am. What I do know is he does travel to the States.
Oh,
and he stays in Boston when he goes. Good heavens!
Fantastic.
It's like you read about these people and you think, well, in one field it would be enough for a lifetime. They can do all this stuff. Just astonishing.
It is, but they're also, it showcases this need for balance. You look at the Herschels and you see that in terms of their musical passion plus their astronomy. And that need for balance is there for a lot of individuals, and especially those of us who take on astronomy as a hobby as well. It's a part of you, and it overlaps into the rest of your life. So all of your passions, my daughter's been dabbling in art, but every now and then she'll sit there and she'll do art of space because that's, on her mind.
Yeah. Yeah. Even Paul Dirac, the British theorist, who was, he was apparently one of the most single-minded people who knew him ever met. But it turns out some modern biographers found out that particularly when he relaxed, he ended up teaching in Florida after, I think it was at Cambridge. And at that time, even though he didn't do it before, it turned out that he liked movies, and some of them were quite silly. But no one would ever have guessed. Even a character like that, it was sort of balanced.
I'm just picturing Paul Dirac now at the talkies, watching some of those wonderful ones when music first started to be played in the theater at the same time as the image was being shown, before we actually figured out how to combine everything together in one.
Yes. My computer is still capable of uncombining them at times. So what do the kids have for supper?
I will admit to falling a little bit behind on that, and I've left them to their own devices. They were both busy, like working in their rooms, and my daughter actually has stepped up to help lead a girls' STEM club that's starting tomorrow.
Oh,
And
excellent.
so one of our outreach colleagues, Diana Phillips, who is one of the NASA educators who's here in Canada and in the Montreal area, she runs these programs. And so she was looking for new volunteers because a lot of the previous volunteers are now university grad students and they're kind of off on their own. And Tara stepped up and she said, I'd love to do this. And so today was her preparation day for tomorrow.
Oh, excellent. Good
Yeah.
heavens.
So she was like, I don't want to talk about any of this right now. I need to do this. And I said, all right. I'll figure out dinner when I finish at 9. And so you figure out dinner whenever you're done. They're both teenagers now, so I don't have to worry about them quite as much, which is good.
Oh, good.
Yeah. We have a lot of awesome, our regulars in the comments, which is great. One of the nice things about the GSPs is there's now this group in the audience that all know each other. They all see each other online. And so the chat is just so robust and so fun to be involved in. So even when I'm not on, I'm sitting there in the chat saying hi to Norm and hi to Harold and Beatrice and Book and all of them. And so it's lovely during these breaks to just see their messages popping up.
Oh, that's really great. Well, I mean, Scott has made a community happen, in effect. This
Very
idea.
much.
You can't take credit for it, really. I mean, it is the confluence of the presenters, the audience. Often the audience, gets inspired to be on Global Star Party, which we invite, and so it's great. I love though seeing people from all over the world, popping on for the first time. And checking it out. We had someone, Beatrice is in Belgium. We've got people in Europe. We've got, not that Belgium is not in Europe, it is. We've got people that pop in from China, the Philippines. It's just wonderful. And the thing is so cool about the technology that we have with Zoom and broadcasting software and everything. I can sit here on my desktop, and conduct a meeting with members all over the world and simulcast it. Essentially for, very little cost, so it does require dedication to do it. But, Gary Albin says, don't forget about me here in North Cuba.
And did you see Norm was asking us to start singing so that YouTube shuts us down right away? They'll be like, no, copyright. You can't sing that song.
That's true. We have had presentations blocked from time to time, but
oh, good heavens, you're
we
kidding.
usually do fight it. One of the things that is kind of a tragedy, I think, is sometimes NASA produced product, the full images of the moon, these kinds of things are claimed as copyright by private companies, that they maybe used a NASA segment in one of their television shows.
You've paid for it. Everyone in your country's paid for those, though.
That's right.
That's crazy.
Chris Kerwin was talking about this because his Facebook shows were constantly getting pushed for copyright by different individuals for no reason. Like it was just, they would constantly claim copyright. And so he moved over to YouTube for a little bit less of that sort of a problem, because he doesn't have any proprietary music or anything. He just shares the images that he takes of the night sky. And people are like, nope, that's a moon. That's mine. Nope, that's the sun. That's mine. It's like,
Right.
No, it's not.
Yeah. So I think that there is maybe some companies that put out content, just claim copyrights just so that they can use it maybe as an asset, maybe an intangible asset for their company. I have no idea, but it's frustrating at times.
Yeah.
Yeah. Well, it's at times like that you'd wish that total perspective vortex that Douglas Adams invented
Yes.
in the Hitchhiker's Guide would be perfect so these people get some sense of perspective.
Yes, that's right.
Perspective is a rare commodity.
It is something though that astronomy does give you once you're involved in it, and you can start to understand the distance relationships and the sizes of things. And more than once I've taken people out observing, and they get the feeling that they are insignificantly small.
Yeah.
And
Yeah.
so I find that
Mhm.
that aspect of them being humbled,
Mhm.
is actually very important. And
Yeah.
so I tell them, look, yeah, physically we're incredibly small, but your mind is as vast of the universe as you can perceive. So
Mhm.
Well, I think it's interesting that as a sense of scale, we're practically halfway between the smallest and the largest, which,
yeah,
and that's a weird kind of centrism, I guess.
Yeah. Yes.
We're in the center because we're right the correct size.
It's all about us.
maybe our size, maybe our condition has led us to believe that in this centrism view that we are often afflicted with.
Yep.
Yeah.
It's also the case that there's a limit to our seeing, right? In the microscopic world, we can get down to the electron clouds around an atom and the reaction from the nucleus when you can find ways to probe it, but that's as far as we can actually measure. And so when you get down to that scale, we believe that nothing's smaller, but we used to believe that about, molecules. So
Yes.
as we dive further and further in, Gary's mentioning the Voyager photo, which is, absolutely one of the, and Carl Sagan, his voice over top of that photo is always in the back of my mind.
Yes. Right. Well, it's interesting you're bringing up Carl Sagan, because the next Global Star Party next Tuesday, November 9th, is his birthday. And so
Oh,
the
nice.
Global Star Party theme is going to be the inspirations of Sagan.
Oh, wow.
Yeah. So and I think that everybody that has been on Global Star Party has been inspired by him some way or another. So, but great. So, Jerry, I'm going to have you join us for a presentation from the Mark Slade Remote Observatory. Jerry Hubbell has done more broadcasting events with me than I think anyone else. We're coming up on at least 200 programs together, and so he is a inspiration to me because of not only because of his knowledge, but his willingness to put himself out there to share what he knows and to get other people inspired. His focus often is science, but he has engaged people on all different levels in amateur astronomy, and he's also engaged people in professional astronomy as well with his pro-am collaborations and stuff that he gets involved with. So, Jerry, I'm going to turn this over to you, man.
Thanks, Scott. I appreciate that. And this is, for those that may not know, I imagine a lot of people know, this is my second career. My first career was in nuclear energy, nuclear power plant instrumentation. So I've been a long time into technology and electronics and the sky, basically. So all that stuff came together for me about 8 years ago, 9 years ago now, with Scott. And I appreciate the opportunity Scott gave me to further my work with him and the systems that we work on every day. So, and the Mark Slade Remote Observatory is an example of that work that I've been able to do over the last few years, along with others. Dr. Myron Masuda is a significant contributor along with me. So I'm gonna share. So today's theme is worlds, right?
World.
So I'm gonna be showing some small worlds, some minor planets, and how we use the observatory to track them down and photograph and measure their position. So I've done this a couple other times on different programs, but I think it's good to for people to understand what's involved in the technology that we have to do that today. And so I'm going to share the observatory. This is the observatory desktop. Can you see that?
Yes.
Now it looks pretty busy because I've got a bunch of little windows up, and this is, I use Maxim DL, and that's what these windows are that are here to do different things. So currently I'm imaging the minor planet Mnemosyne. I guess that's how you pronounce it, Mnemosyne. I don't know if you
I
can
don't
see
know.
that. It's pretty tiny text there. That's a Greek name. But that minor planet or asteroid is currently a 12th magnitude object in the sky, and I use the Minor Planet Center's database to look up. Currently, there's nearly 1 million minor planets in the Minor Planet Center's data catalog that have had orbits calculated. So
A
they're
million.
they're keeping track of a lot of objects, you know, and then there's millions more that are out there that have been maybe observed and photographed. They're very faint. So, but this one's a 12th magnitude object, and so I pointed the telescope to where the predicted position of that object is based on the star chart. Okay, and then I take an image. Let me go ahead and take another image. I'm just taking 30-second images right now, and and you'll see it'll come up. It's pretty much this field right here that I'm showing here, but I want to take a fresh image so we can do a fresh measurement of its position, because asteroids, minor planets, are moving all the time because they're solar system objects, right? So they're in orbit around the sun, out in between Mars and Jupiter. This in fact, I can show you where this object is right now. So you see that. This is a website provided by NASA JPL that lets you plot the orbits of minor planets, and also give you, there's a small body database lookup for this asteroid. There's the name right there, Mnemosyne. And I guess this is the previous designation. So there's some detailed numbers about the object. This object is measured to be around 112, 113 kilometers in diameter. It's probably not a perfect sphere, of course, but here's the orbital view of where this object is, and it's currently right here in the sky. Here's Earth right here, okay? So, and then Venus is over here, but this is where it's located in the orbital view. And there's Jupiter right here. Can you see that? And then,
Right.
so this is where the asteroid is. So that gives you an idea of what we're looking at. And so there's a new picture that I just took. Okay.
Okay.
Now I've positioned this object close. I mean, I did a plate solve previously and adjusted the telescope to be calibrated to the sky. So that's what a plate solve does for you when you do a sync on the telescope. So I'm going to go ahead and process this images, do another plate solve. Okay. And it calculates the center of the plate. I'm not going to adjust it. I'm just going to leave that solve there, and then I can go and you look at this, see this information window.
Mm-hmm.
When I move the cursor around, I've got this aperture circles that I can center on objects, and it'll tell you, like this right here, is a catalog star. You can see here it says catalog star. It gives you the coordinates of the catalog position, and then it's got the image position. You can see it's pretty darn close to the same numbers. Within 0.2 arc seconds. So that's how, even with a backyard telescope and set up correctly, you can do very precise astrometric measurements with this device. So that's very important when you're doing asteroid position measurements. So you got a timestamp and a position for that time. And that's where what you need to be very precise to calculate the orbit. So Nemesen, so I've got a coordinate right here for Nemesen, okay? And these are J2000 coordinates. That's what the plate solve does. So this is 21 hours, 39 minutes, 51 seconds. I think this is it right here. Let me blink on that or click on it. So the position of Nemesen, according to the catalog, is 21, 39, 51 for right ascension. Nope, that's not it. It says the catalog star. So where'd she go? 21, I think it's right here. So I just did a plate solve and readjusted. I didn't sync the scope. So there's the asteroid there, I believe. So it's because it doesn't come, it's a bright object, first of all. See, these other bright objects have catalog numbers. See that pop up as a catalog star? This object is not. Okay, it doesn't have a catalog number. And if you look at the right ascension, it's 21, 39, 51, which is pretty much what the star chart position is. And then the declination is -3, 29, 54. Now, and this is pretty interesting. So 29, 54. So the catalog position is not quite right. It's a little bit off, a few seconds in declination. So one thing we can also do is compare it to the UCAC catalog directly with a program I use called Astrometrica. So I believe that's the object right there. Okay, so you can see it's off the center a little bit. But what I want to do is I'm going to save this image as number 3. Okay, I'll save that. And then I'm going to pull up the Astrometrica, which is an awesome program. It's been around for a long time. And I'm going to load up that image we just took. Nemesen. So there it is. So I just loaded the image. It's gonna read the time and date of the image off the FITS header. I can show you that in a little bit, what the FITS header looks like. And then I'm going to go ahead and do a plate solve with Astrometrica on this. And it's got a position of that the scope or the mount said it was that's in the FITS header. It says, okay, I'm pointing at this direction. This is where the approximate center of the plate is. So it's going to say use that as a starting point for the calculation for this plate center. So then it solved it, okay, and those numbers might be too small to read, but we're within 0.1 arc second in terms of the precision of the fit, okay. That means the error across the whole plate, any position error is within 0.1 arc second, which is really great from the catalog values. So now, I know this object's near the center, okay? So I'm going to zoom up a little bit, get in the center of the plate around this area, and then I'm going to use this tool called Known Object Overlay. So previously, I updated the catalog of asteroids from the Minor Planet Center. So it should identify a minor planet. I think this is it right here. I don't know if you can see that red there's a little bit of red text in a box, okay, right here. All right. And so this box is a little bit below where the actual image is. So this kind of demonstrates the importance of doing these measurements, okay? So even though the catalog value calculates the orbit and says this is where the position should be, where this box is at, I'm just kind of outlining, you may not be able to see it on your screen, but that's where the box is. But the asteroid is right above it. If the calculation was 100% correct, then it would draw the box around the object, but it's not quite there. So that tells you that the calculated position is not quite correct based on my image. And so you basically would submit this measurement to the Minor Planet Center, and I'm gonna go ahead and I'm not going to do that now, but I'm going to see what object it finds. That's the object right there. It's within 0.1 and 0.3 arc seconds. Okay, is the position of the object. And its magnitude is its calculated magnitude is 12.3. Let's see what the I don't know if it doesn't really tell me the calculated magnitude. So that's how you do that. So that's how we determine that that's actually the asteroid. Now, I'm going to break off here and go to the next speaker. But when I come back, what we'll do is we'll take another picture of this object, and hopefully I'll be able to show you how it's moved in the intermediate time. That would be kind of cool, so that you can see that yes, it is the asteroid, it's moving, and it will demonstrate that. So
Great.
back to you, Scott.
Thank you very much, Jerry. It's so cool to see science being done live and broadcast all over the world. So
yeah, yep. Measurements are cool. I've just been into measurements for a long time.
Very awesome. We had a couple of comments here just before I go to the next speaker. I'll split these comments up when you come back. But Josh Kovac made a comment. He said, Jerry, I'm curious if you have any input on how I'm putting together and annotating my photographic observations, and if it's useful for scientific submission. Has he sent you work to review?
What's his name again? I'm sorry.
Josh Kovac, Kovac.
No, I don't know that I've gotten any images from Josh. I don't think so. I don't recall anything. But one of the important things about taking images, and when you get into it, you'll take hundreds or thousands or 10,000s of hundreds of thousands of images eventually. So you got to come up with a good scheme to name your files, and it's important to organize your files in directories. The way we do it at the Mark Slater Remote Observatory is we have directories. We have a master astrophoto directory, and then we have the telescope that we're taking it with as a directory. Mm-hmm. And then underneath that we have the date. So we create folders on every session. We create a date folder, and it's the starting date of the session is what we use. And then underneath that, when you different programs, when you save files, you can add different information to the file name, not just the object name, like Nemesen, like this one. I named it 57 Nemesen, which is the asteroid number. But also you can have information such as the exposure time, and the date and time stamp is always on there too. So, and then the FITS header, that's one thing I didn't show you real quick, is the FITS header. I'll show you that when we come back, what kind of information's in the FITS header. But get an organized, to keep track of all those files and all those images, it's good to have good file name system and directory system to do that.
Right. Okay. Well, up next is Carroll Orridge, president of the Astronomical League, and he's going to talk a little bit about the 75th anniversary event.
Thanks again, Scotty and Jerry. Thanks for the interesting presentation you just gave. I learned a lot there. I always do at these events. Lots of familiar faces, but some new ones as well. When we are beginning to talk about celebrating our 75th anniversary of the Astronomical League, I was, as I was listening to the talks tonight from our Canadian friends, concerning getting younger people involved. They were specifically talking about college-age students involved in astronomy in an active role. It made me think, and I'm going to get my screen up here. Go down to the very last one, right there. There we go. It's interesting, as we were doing the research for our 75th year, we realized that maybe 30 years ago, 30 or 40 years ago, there were a ton of youth involved in astronomy, and specifically from our point of interest with the Astronomical League. There were a good deal of youth clubs, sub-clubs within the main clubs scattered across the country. And in many cases, they were in leadership roles. It was just amazing to uncover that information. And I know all groups now are trying to appeal to youth, and rightfully so, because that's all of our future when to take our place as we go further. But it was very incredible. Again, we're seeing positive signs, and Scott's operations have been a big part of that, as far as making those opportunities available where people around the country and the world can watch astronomical type events during the COVID. And that's a big part of why interest is coming back in astronomy. But it'll be a different interest as far as the youth. And I think we're already seeing that. It's not what we saw 30 years ago. It's a different time. And we've got to adapt as organizations in order to make room for the youth and let them take their place. Our featured speaker for Astronomical Live on the 15th, which is talking mainly about the 75th anniversary, will be Alan Dyer. He's been on this channel before, I believe, a couple of times at least. And his talk will be on how to photograph the lunar eclipse. And it's going to be 97% total, the one upcoming, November 18th and 19th. In addition to that, we're going to have special guest appearances from Stella Kafka from AVSO. Stella's been on here as well. Richard Smuty from Alpo will be there, and we'll have a representative of IDA and other people as well. And David Levy, and of course, Scott makes it all work. He will be here as well. Chuck Allen, Vice President of the League, Terry Mann, Secretary, and also a great part of making this successful, our collaboration with GSP and myself. But hope everyone will tune in for that. And I'm just skimming the top of what we have really found out during our research for the 75th year. There will be a multitude of speakers. It's been really a fascinating experience, and we've revived some interest in membership as we've reached out to the 10 distinct clubs that were original members of the league back 75 years ago when they came together and formed it. And in many cases, some of those clubs have been real active in the league in recent years. However, during these past few months, several of those have come back and said, we want to be more active because at one point we were active in the league, and we see lots of opportunities to really create some interest and help us with the youth movement as well. So And with that, I think I'll turn it back to you, Scott, and hope you'll
All right.
join us on the 15th of November. That's at 6 o'clock, I believe. Don't think 7 o'clock Eastern, 6 o'clock Standard. And so hopefully we'll see you all then. Back to you, Scott.
Thank you very much, Carroll. Thank you. Okay, so we'll switch back over to Jerry Hubbell, who's finishing up his observation of, I forget which asteroid it is.
It's Nemesis.
Nemesis. Okay.
And I'll show you how we'll slew over to another asteroid real quick and we'll take an image and measure it also. I'll show you how we can go from one to the next pretty quickly. So let me share this. So I want to show you first, I want to show you the FITS header of what kind of information is, can you see my screen now?
Yes.
So on MaximDL, for any image, you can show the detailed information. I'm hoping this will show up big enough for you to see. This, I can't really control the size of the text on the program. So you see these parameters here? Like this one is a date of observation. Okay. Can you read that, Scott, or is it too small?
It's pretty small. Maybe you could read it for
Yeah,
the
let me do something here. I'm gonna try something here real quick. I'm gonna start up Notepad. And I'm just gonna cut and paste and make the text big so you can see this stuff. Copy, paste. All right, there we go. Is that better?
Yes.
All right, so this is the FITS header, and it shows you a lot of good information. Like, for example, this is the date of observation. And the nice thing is that it goes down to the millisecond level, which is kind of cool. And what that time is, that's the center time of the exposure. So if you're doing a 60-second exposure, it's going to be the center time of that exposure. Oh, I lied. You can select the center time, but this is the exposure start time. So if you want to do the measurement, when you do the measurement for the asteroid position, it calculates for Astrometrica. You tell it what the exposure time is, and you tell it it's the start time, and then it calculates the center time, because that's the measurement position, is the center of the exposure. So that's important to understand. And then you've got other information that gets developed. One of the things is also it does measurements of the image. It tells you what the mean full width at half maximum of the image star of the basically the average or the mean value across all the stars. And that's a good indication of how well focused it is. So there's a lot of other information you can see that's in here. You'll learn about that. If you get into the science imaging, you'll learn to store images in the FITS file format, which includes this header information, and you'll get into what those things mean. So I just want to introduce that to people. That's part of the image. And so let's go ahead and take another picture. Let's do something real quick. Let me new. Let's save. I'm gonna go to Astrometrica, and I'm gonna take this. I think this is the measured. See this information here? This is the measured position and also the measured magnitude of the image of the star, of the asteroid, actually. And I'm trying to see how I can, and this is the time and date. So I'm going to accept this. All right. Actually, I think I've got to do this first. I got to select the object and then accept it. Okay. I'll make a note. This is there's nothing to see here. There's a way to select the note on the image, okay, when you report it, but I'm not going to select it. I'm going to accept that. And then I'm going to go here. I'm hoping I can find this quickly. I've got my log file. I've got my, the report file. Here it is. Okay. Well, this is an example report file. And here is the data. Is that right? That's not it. Up top here, maybe. Here it is at the top, not the bottom. So
this is the Fitz header file?
this is not the Fitz header. This is a recording of the data that I've taken over a certain amount of time. Okay, so this is an older file that it got added to. So this is the measurement I just took right here. All right, so I'm gonna copy this, and I'm gonna put it in this notepad so we can compare it to the next measurement I do. So when we take a new measurement, we'll do a calculation. We'll take an image, a new image. We'll do a measurement, and then we'll compare it to this, and then we should be able to see how the asteroid has moved. Okay, that's what I'm trying to demonstrate here. How the asteroids move. So the coordinates should change. Okay, the RA and the declination. So let's minimize that, and then we'll take another image. So I'm going to start, and it'll take about 30 seconds. And so over time, I don't know how long it's been. It's probably been what, 20 minutes, 20 minutes probably since we took the last image. And we'll be able to see exactly how long the difference in time is once we take it and do a measurement. So the first thing I'm going to do is I'm going to do a plate solve, and I'm going to identify, we see this asterism here. It's going to be near this position. All right, so there it is right there. Let's see. I believe that is I'm going to do a plate solve first for it to show me the information for that object. All right. I did that. So there's the information right there. Okay. And I know that's the asteroid. So now I'm going to save this into my number 4. Now I'm doing I'm manually doing these, taking these pictures and saving them, but Maxim allows you to set up a schedule. You take a series of photos over several hours if you want. And you can set the name up and everything, and the suffix and the prefix and all that stuff to save a series of images that you can do a time sequence for light curve photometric measurements, or for position measurements. You'll be able to do that. So let me close this. I'm going to load this new image, number 4, that we just took. And again, it reads the Fitz header and says this is when it says mid exposure time right there. Can you see that? It says time mid exposure. So it calculates the mid exposure because it knows how long the exposure was, and it knows when the start time is. So that's what it does. The next thing I'm going to do is I'm going to do a plate solve on this. I'm going to say okay. And that's pretty interesting. So now, I guess I've got to close that one. Let me do that. I'm going to close the other one. So that it only comes up with the one. I got to close this. I'm going to try that again. All right. So it solved it. So here's the center of the plate, thereabouts. Right here. So you see these green circles. I'm going to zoom up. So I don't know how good you can see the green, but any catalog stars have green circles drawn around them. Okay. And then I believe this is the asteroid right here. I'm gonna move it over a little bit. Right here is what I think is the asteroid right here. So let's do a known object overlay. And yep, there it is. And you can see the predicted position is still away from the actual position according to my image. So there's the there it is. So I'm going to say, okay, tell me what it is. It's going to come up and say, yep, it's identified it. It's and the measurement precision is still the same. I say, okay, and I'm going to accept it. Now it added another line to that report file. So let's view the report file. And so now these are the two different measurements right here. Okay, so I'm going to copy both of those and go back to our thing, and I'm going to paste it on here, Control V. Now this is very interesting. Here's the time. Okay, 11. That was the first one, and this is the second one. You can see there's a little bit of time in between. This is in days. So that's decimal day. Here's the right ascension of the first measurement. Here's the right ascension of the second measurement. All right. You can see it's different. Here's the right ascension of, or the declination of the first measurement. Here's the declination of the second measurement. Okay. See, there's it moved 4 arc seconds in declination over that 20-minute period. So even as slow as these asteroids are moving, you can detect it over just a few minute period, the change in position with a backyard telescope, which is pretty amazing, the precision that you get with these measurements. So the last thing I want to show you is I'll show you how we can move quickly to another asteroid. Okay, so let's go back to our star chart. And I'm going to pick out one. I'm just going to pick out one that's near here. So this one, that Benjamin? Oh, not that. Oh, yeah, this one here. I don't know why it doesn't pop up. There it is, 976 Benjamina. Okay. So all I have to do is right click on it. It gives me information, but I can center it in the target. So the red shows the target. We're over here on 57 right now. So I'm going to move over to this other asteroid. Now it's a dimmer asteroid. It's going to be its 15th magnitude, I believe. So I'm going to slew to that object. So watch the chart. We'll show the telescope moving a little bit. All right. Now it's, let me track the telescope. So there it is right there. Let me go zoom up a little bit more. Okay. So now, let's see, it says 15th magnitude. So it's going to look dimmer. Okay, so now let's take a quick picture. I'm going to zoom out a little bit. And then we'll identify this asteroid. Now it makes it easy when you can do a plate solve and know exactly where your telescope's pointing to center an object. Now you know that that object's going to be close to this crosshair, right? It's going to be very close to the center of the image once it's loaded here. So there's the new image. Whoop. Move this over a little bit. All right, so it's somewhere in there. We don't have any idea right now. So we have to do a plate solve first to calibrate the frame for astrometric position. But once we do that, then we can start kind of looking around to see which object. So if you see on this information window here, if I move over a star, it tells you the catalog star will show up as information. So it knows that's a star. It's not the asteroid. And we know this is going to be a dim asteroid, right? So that's a catalog star. That's a catalog star. That's a catalog star. Okay. So now we know that's a catalog star. Now look here. There's an object here that's not a catalog star. So let me zoom up on this. Oh, look there. There's two objects there. Isn't that interesting?
Mm-hmm.
Now, I had no idea about Benjamina. I'm not going to say this is a twin asteroid or or one asteroid. It's probably just a coincidence that there's a star next to it. But again, when I'm on this position, it doesn't identify as a star. So I'm really curious about this. So let's look at this position, okay? So it says it's 2151.13, okay, and 21. So that's not even it. That's just a dim star. That's just a dim star or a pair of dim stars because the J2000 coordinate for this asteroid is 2151.41. So I'm not anywhere near that. That's 2151.13. So I need to zoom out and move my cursor around. So you can see how it updates the cursor position. So I want to be near 2151. What is it? 2151.41. So that's going to be over here somewhere. All right, so there's 41 right there. Is this 351.04 for declination, 352.29. So I'm not anywhere near. So let's see.
So you're looking at the predicted position.
I'm looking at the predicted position and then looking for it on the chart. Right.
And your cursor is updating RA and DEC as you move over objects.
Right. So now, that you can hunt and peck and look for this thing for a while, right? You can see how I've got to look around and see where it is now. I think what the problem is now is I took the picture. We saluted the object. I took the picture. I assumed it was near the center, but that may not be the case. Okay. So now one thing I can do to really cheat is to save this image. Okay. And I'm going to name it 976 Benjamina. I don't know if that's pronounced right. That's what it looks like. Benjamina. All right, 1. I'm going to save that, and I'm going to load it up in Astrometrica and let Astrometrica tell me which one's which. Okay. Then I'm going to close this image. File, load images. This is what's good about these tools that we have today. I mean, they really help you. They really help you a lot in understanding this stuff and also identifying things because, you know, if you're trying to do it manually, you can get frustrated. And because you don't even know if your telescope's pointing at the right position. Early on when I was doing this, I couldn't even get an asteroid that I was looking for on the image at all. It took me a while to figure that out when I first started. And then I discovered plate solving, which is, this was 10 years ago or 12 years ago, actually. It wasn't as widespread as it is today. So now I'm gonna go ahead and do a plate solve. And it did the solve, which is great. Look how accurate that is. 0.08 arc seconds, 0.09 arc second precision. That's amazing.
Jeez.
Yeah. So I'm gonna zoom up a little bit. Then I'm gonna use the known object overlay to see if it can identify Benjamina. So let me zoom out. I don't see it on there. Oh, let's see. We got a couple asteroids here. This might be it here. I'm gonna move this out of the way so I can move it in the center a little bit. 19. This is 947. I can't see what 976 Benjamina. That's the file name. 51, 54, 4009. I don't think that's it. Sure does. That looks close to the it's really not very bright. Might have to take a, not it. But there's supposed to be an object there, but it's very dim. So I'm gonna say I'm gonna see what objects are in this location. See what it is. It says I'm 8 arc minutes off, 3 arc minutes off. So that's not near there. So let me cancel. Wish I could read this red text a little better. It's hard to read. Nothing there. Maybe this is it here. Let's see. See what's here. Oh, that's it. Found it. So that's a measured 15.2 magnitude is the measured value, and it's the catalog value or the current value should be 15.4. So that's pretty good. So this position, again, let me cancel this. You can see down here, let me get it in the center. You can see the calculated position, that box, the red box there is a little bit below where the measured position is. Okay, that's kind of interesting. So I'm going to go ahead and accept that. And accept it, and it'll store it in that file. And I'm going to load it up, and we'll look at the position, and we'll compare it to I labeled it wrong. Let's see. Oh, why didn't we go there? Maybe I got the wrong file. MPC report file. No, maybe I didn't save it. Let me do this again. So Bear with me. All right, so I'm gonna identify that guy again. Okay, accept. All right, so you can see it's got the purple identifier and it's got the red box. So now it should be in this file now, like it was previously. But I don't see it. I wonder why that is. Oh, I know why. Because it actually puts these in order. And this is 976. Let's see, where's it at? Oh, not showing up. Oh, nope, there it is. There it is right there. Oh, come on. I did two measurements that are basically the same, so I'm going to copy this one. Close that. This is Benjamina coordinates, and so it says that it should be at 21, the predicted position, 21, 51, 41, which is pretty close. And it's -3, 52, 29. It's right on the money, pretty much. So that's how you go from one asteroid to the other and do another measurement and by hand. And you can automate this. So you said there were other questions, maybe a couple other questions that were from before,
Yeah, let's see. So
but I'm not taking up too much time.
it was very interesting. Well, one comment that Josh made, he says, I feel like the barrier to entry submitting to the Minor Planet Center is very high. I read through like 10 different pages, and I still have no idea how to actually do it. I did recommend to Josh that he gets training from MSRO Science. And, you know, it really, Josh, it's just like anything in this amateur astronomy hobby. If you have someone that knows nothing about a telescope and you just leave them alone with it, they might be able to do some things with that telescope and find things by accident. But there's nothing like having somebody take you under their wing, showing you step by step how to find galaxies, deep sky objects, this kind of thing. Most amateur astronomers have had this kind of breakthrough experience before by having a mentor, you know, and so that is one of the things that the MSRO science program does is they have this kind of mentorship, and they can get you observing and recording data and submitting data like a pro. And so
now I was kind of free forming it, right? I was talking off the cuff, but there's procedures behind that you learn. So there's a couple things you have to go through to be able to report to the Minor Planet Center. One is to get your location certified as an official location and where your observatory is at, where you're going to take your measurements. Because it's very, very important that they know exactly precisely what the location on the Earth where you take the measurement from to do the orbital calculations. So there's a process to go through that. And part of it is what I've demonstrated tonight. You just there's a series of measurements you take over few week period with several different minor planets. You submit that data, they look at it and see what the quality of your measurements are. And then if they're satisfied, they'll assign you an observatory code. And then once you do that, then you can submit measurements to them. And I've gone through that process twice, one with my home location here at the end of my driveway, actually, and that's my observatory code I-24. If you look it up, India 24. And then the Mark Slater Remote Observatory is identified as Whiskey 54 as the location, as the observatory. So you have to go through that process if you're interested in getting yourself location certified, and then you can take measurements, but you've got to learn how to take the measurements first. And there's a procedure to that. It's not magic. Most people can do it. If they're into astrophotography, your gear that you have set up for doing pretty pictures will do the work. You don't have to do anything different. Typically, scientific imaging and measurements are actually easier than doing beautiful pictures, because you can deal with bad seeing, you can deal with somewhat smeared stars, not perfectly round stars with scientific measurements, depending on what the precision is that you're trying to get. But overall, science imaging is pretty easy to get into. It's just learning the techniques and the technology behind it that are available to everybody.
Right. I've put into the chat how to contact Mark Slater Remote Observatory, and you can get started there. It's not the only way to go, but I will tell you, it's a tried and true thing, and they've had students from all over the world sign up for it, and they are contributing to science. So from there, they'll open the door. That opens the doors to all kinds of pro-am collaborations that you can do, or you can just be a regular contributor to like the Minor Planet Center, for example. So that's great. Okay.
So that's my, so I talked about small worlds.
That's awesome.
And tonight's theme.
Thank you. Thank you, Jerry. Okay, well, up next is Dr. Marcelo Souza. He is running a program called the Young, I always forget the name, the Young Stars of Tomorrow. That's what it is. And the Explorer Alliance Mentor Program has joined up with this program to help inspire and teach students down in Brazil, which include quite a number of schools and students down there. I've been on one live program on there so far, and I plan to be on more. But Marcelo, maybe you could give us an update of what's happening.
Good evening. Nice. Thank you for the invitation, Scott. Ever is a great pleasure to be with you here and with all the participants here. I will share my screen because we began the activities in school since October. And this is a project that we are developing with the support of the US consulate in Rio de Janeiro. I will share my screen now. Okay. Here. Okay. This is the name of the project, Young Stars of Tomorrow. We began the project on September 30, and the project will be developed until here is the support of the mentor. Thank you, Scott. Scott participated in one of the video conference, and we also have the support of AWB and Charlie Bates, Solar Stone project. Here is where we are located here in Brazil, in Rio de Janeiro state, and we live in the north region of Rio de Janeiro. I don't know if you can see my.
Yes.
But in this region that we live, here you have a nature park here, and here is our city, Campos dos Goytacazes. Here is the place where you have the oil from. Most of the oil from Brazil is coming from here, from the ocean. Almost 70% of the oil. And we began to develop activities in schools on September. This is the first school that we visited. Then the project will be developed from October 2021 until October next year, 2022. We are going to visit more than 40 schools in 6 different cities from our region, and we will involve more than 2,400 students in this project. Even we are yet in a pandemic period here in Brazil. I believe that's in all the world. Even with these problems, we are developing activities in schools because the schools open up here. We need to be careful, but the schools are working. Here, what are the main lines, main topics of this project? We are going to talk about astronomy, space exploration. Students will learn how to make apps for smartphones, Androids, and also they will know about the cartoons, how to make cartoons. Here, students are looking for the sun. With his sunglasses, we receive a donation from Stephen Hamsden. He sent 3,000 glasses for us to give to the students here. And here is César, one of members of our astronomy club that are doing activities in schools here. And here she was talking about the NASA and when began about the space exploration. And here we have two students that are talking about programming. She's talking about programming. She talks about arts because we want to associate everything with astronomy here, not to motivate the student, because we know that astronomy is one of the main areas of science that motivated people. Then we use astronomy as a door that we want to open to show science for the students here. And here is, you can see what we are doing in school. Here is a report in Brazilian TV about the project. This was the first school that we visited here. And we already visited 8 schools since September 3rd. This was the first. We are talking about astronomy here. I go with a long, then we talk. And after this TV report, we have more students that want to participate in the project. And also we are choosing 5 students that they will receive a scholarship during 9 months to work in the project. 5 students from fundamental schools and high schools, from the schools that we are visiting. Then you see that you have the students need to be distance between each other due to the difficult period yet. Me again, I show it. 2 students that are involved in the project. One of them now, she is studying in high school, but she is an artist. Then she is motivating students to develop projects. She studies in a public school here. Another student that she is a physicist. Now she is studying a master degree. She wants to get in astronomy in the city of Rio de Janeiro. And this is what we are doing here. Out the place that we are going, we receive the support of the municipal government. Here you see the mayor of the city. This is the city of Santa Maria Madalena, the other city that we already developed the project. Then we have the students here, and another, she's talking about programming, arts, and now we have workshops with the students after the presentations, and where you talk about astronomy and we try to find new talents. This is the main objective of the project, that we want to find new talents in these schools. The students will be invited to be with us every 15 days to talk about science and to know more about programming and about the arts and how we can develop projects that involve arts, science, and program. Here, another project. Here, they are looking to the sky here to see the sun with the sunglasses. And we received now material from NASA that was sent to us by the US consulate. Then the students that are most motivated to participate in the project will receive a NASA 3D, that is to see images, stereoscopic images, glasses, stickers, NASA stickers, folders, bags, and also a newspaper about the 50 years, a celebration of 50 years of the man on the moon. This is last school. We developed today the project in this school, and we already gave to the students. They looked to the sun. Now they are developing the apps. Here is the part of the arts, and here students receiving the NASA folders and the stickers and the NASA 3D. And here is the newspaper about the 50 years of them. Then we organized an international video conference with Steve Hamilton, Scott Roberts, already. Thank you, Scott, to participate.
Thank you.
And Vivian White, that these are the first three. Every week we have video conferences with researchers and the educators from United States and Brazil. And the next one will be with Mike Simmons, Eduardo Gonzalez from NASA, and Dr. Rosalie Lopes, that is a Brazilian that works at NASA. And this is our project that we are developing here in Brazil. And we hope we can find new talents and we can motivate the students. Even we are living in a very difficult moment, but it will be an opportunity for them to know about the science. This is what we are doing.
Yeah, that's wonderful. That's great. It's inspiring to see so much youth getting so involved in science and astronomy. It can only really be felt and understood when you attend one of Dr. Marcello's programs. And I've had the honor of doing that once. We'll do it again virtually as we're going along here. But I also want to point out too that Dr. Marcello, Souza, along with David Levy, are the editors of Skies Up magazine. This is a printed copy, but it is available for free as a download, and it is truly a global astronomy magazine. This next issue that's coming up, the one that's out right now was primarily about Saturn, but the next one that comes out is about dark skies. The magazine includes star maps by Will Tyrion. It's got lots of data on astrophotography, commentary from Dr. Souza and also from David Levy. I also write a column in it, and it's just a really great magazine to be involved with. The next issue comes out this month, and I will put in a link to where you can get your own copies, digital copies of Skies Up. So that's great.
It's a fantastic experience because it's a fantastic magazine. You have people from different countries that send the articles for the magazine. Then we also can know what they are developing in different countries. There is a great opportunity to know people from different countries around the world.
Yes, yeah, it's great. It's wonderful. Okay. Well, thank you for joining us tonight,
My
Marcelo.
pleasure.
You know, it's always a pleasure. So thank you.
Thank you very much for the invitation
Mhm.
and for the support.
Take care. Okay, so up next is Deepti Gautam from Nepal. She was running a little bit late, but understandably because they're having major festivals in Nepal right now. So, which is great. And I reminded Deepti, you're only young once, so you need to go to every major festival you can. So, so anyhow, Deepti, how you doing?
Hello Scott and hello everyone. And yeah, a little bit today. Nowadays, it's been like this is the week festival of Deepavali in Nepal, which is the festival of light, and where we celebrate interacting with our brothers, sisters, and many relatives, and kind of celebrate the light of festivals. So we light the called dio, which is the small vessels made by the mud, and we light that mud, and we worship one goddess. Is she represent this wealth, and today and yesterday it was the main day, so I was bit weak up late night. So okay, so today is our theme is the world, and I relate the world, the planet, our Earth, and what is actually the world is, and what is actually the planet is. A body which orbits the sun directly and is massive enough to be in hydrostatic equilibrium and to dominate its orbits, and specifically the 8 major body of Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. In Earth, our home planet is a world unlike any others, and the third planet is from the sun. And Earth is the only place is known as the universal confirmed to host life. And Earth is the 5th largest planet in our solar system, and it is the only one known for CO2 to have liquid water on the surface. And Earth's atmosphere consists of nitrogen, oxygens, and more solar energy is received by tropical regions than the polar regions, and is redistributed by stratospheric and ocean circulations. Greenhouse gases also play an important role in regulating the surface temperatures. Our region's climate is not only determined by latitude, but also by evolution proximately to moderating oceans, among other factors. Several weather such as tropical cyclone and thunderstorm and heat waves occur in the most area and greatly impact the life. And Earth gravity interact with other objects in space, especially the moon. And as we know, the moon is the natural satellite of Earth, only one natural satellite of the Earth. And the Earth orbits around the sun is about 365.25 days. That is, Earth axis of rotation is tilted with respect to its orbital plane, producing season on the Earth. And the gravitational interactions between Earth and Moon causes the tides, as you know, that stabilize the Earth orientations on its axis and gradually slow its rotations. Earth is the densest planet in the solar system and the largest and most massive of the 4 rocky planets. Earth's expected long-term future is tied of that sun, and over the next 1.1 billion years, solar luminosity will increase by 10%, and over the next 3.5 years by 40%. Earth increasing surface temperatures will accelerate the inorganic carbon cycles and reduction of CO2 and concentration to levels low for planets that is in approximately 100 to 900 million years. The lack of vegetation will result in the loss of oxygens in the atmospheres, making animal life impossible. And due to the increased luminosity, Earth means temperatures may reach up to the 100 degrees Celsius, or in 1.5 billion years, and all oceans water will evaporate and lost to space, which may triggers a runaway greenhouse effect. And All this, and even if the sun were stable, of friction of the water in the modern oceans will descend to the mantles due to the reduced steam venting from the mid-ocean ridge. And I have recently written a small poem in in the dream I have in my dream book I write. I dreamed a dream. It had caused me to awaken. Give me a power to move on. In my dream book, I write. Some dreams are about life, about a love lost and broken. A dream I dreamed last night. I had reached up to the moon. The dream I felt is now taken. To my dream book, I write. My step in the dream, which I created in my imaginations, a dream I dreamed book I write. Some dreams are very light. Good dreams come only one and then. Most dream I dream in night. But it was the daydream comes true the main. I wish to make it right. That leave me happy and more fallen. In my dream book I write. How dream will come tonight until I have reawakened. I dreamed a dream last night. In my dream I write. Thank you. That's my
I
poem.
love that. I love that. That's great. Well, wonderful, DT. So this festival is still going on now, or?
Yeah, it will last up to the 2 days, up to the 7th, 8th November.
Mm-hmm. Well, great. That's wonderful. Thank you for coming onto the program, and enjoy the festival.
It's my pleasure. It's my pleasure to come up here and give my presentation, interact with you all.
That's great. Thank you so much. Okay, so at this point, we will go to another 10-minute break and come back to Adrian Bradley, who's, I think, has some new images to share with us. So thanks again.
Yeah, they're new to everyone else. And my video is slow, and I'm trying to see if I can catch it up to my voice. I'm using a camera that hasn't caught up to everything yet. So hopefully it'll be caught up by the time I do my presentation.
Okay.
To observe with Hubble, we actually have to plan out pretty far in advance. And for the outer planets, what we do is we pick the time when they're at opposition. And that means that it's opposite from the sun, from the Earth's point of view. And that basically gives us the highest resolution view. That's when Hubble is the closest to each planet, even though that doesn't vary much over a year. And the planets are a little bit more challenging because they move. And so Hubble has to find guide stars first that tell it where it's pointing in the sky, but then it has to track those planets. So it has to move following the planet across the sky. And so that has to be interleaved with all the other science program Hubble is doing every single day. And so it's very carefully coordinated to fit in as Hubble then orbits around the Earth. And so it gets planned out down to the minute of exactly which image we're going to take in which filter for each of those planets. So it's a cosmic dance of getting Hubble pointed in the right place, moving in the right direction, and tracking all at the same time. The OPAL project, or the Outer Planets Atmospheres Legacy Program, is an observational program using the Hubble Space Telescope. And what we're doing is we're looking at each of the outer planets every year so that we can build up a time base using the exact same facility and the same instruments, so we can actually track what's changing over the years on each of those planets. And it started really with Jupiter. In essence, we were trying to look at the weather on Jupiter. And as we're trying to understand weather, we know even here on Earth it changes every minute, every hour, every day. And we didn't have that kind of time coverage, but we also didn't even have long time coverage to look at things that changed over seasons. And so we had this big gap in our knowledge where we just weren't getting frequent enough data to be able to trend any of these things. And the idea kind of came about to look at a legacy program where we built up a legacy for Hubble within the planetary community. And in 2014, we started with our first observations of Uranus. And the first thing I think we noticed was Uranus had a very prominent polar cap. It was very much brighter and getting brighter over time. We've watched it over the last few years get much brighter. Neptune, on the other hand, has been really quite interesting. The first thing we noted was it had a lot of bright white clouds, and they were coming and going pretty rapidly at a lot of different latitudes. And so when we start looking at Neptune and Uranus as dynamic planets with changing atmospheres, weather, like we know now for Jupiter and Saturn, we realize that we have a lot of gaps in our understanding. And so we've been able to use the OPAL program to track how much cloud cover we have from year to year. But the other thing we can do with Hubble that we can't really do any other way is look for dark spots. And so the Great Dark Spot was this big iconic feature we saw with Voyager. And when we looked again a few years later, finally when Hubble was online, it was gone. And that kind of surprised us because we were used to the Great Red Spot, which doesn't go away. It's changed over time, but it's still there. And so these storms are not quite the same as what we see on Jupiter because they form and go away on much more rapid timescales. The latest image of Neptune is really interesting to me because we don't see those bright white clouds we've been seeing the last few years. As a matter of fact, the only thing we see in that particular image is this great dark spot. And so in a lot of ways, it brings us around full circle because this looks so much like the Voyager image from 1989. And that was pretty surprising to me, not to see as much cloud activity as we've been seeing in previous years. The OPAL team's actually a fairly small team. There's only 3 of us, but our data is immediately available to the public and any other scientist that wants to use them. And so we do that as well as our own scientific analysis. I think having so much Hubble data now, there's just so much in there to study. And as a scientist, that's what drives us, is trying to solve mysteries, trying to look for new mysteries. And so having these long-term data sets with just such rich numbers of features in there, there's always something to go look at. And it's certainly going to keep us busy for years to come, even when we're not getting any more data.
Well, everyone, we're back. Hope you enjoyed that little video segment from NASA and the Hubble Space Telescope. I guess on November 1st, Hubble, the telescope went into safe mode. I haven't been able to completely track that, but I think that the technicians have either already figured out how to get it back online or will very soon. So, but they say that all the instruments are healthy, so that's awesome. We have had a great run tonight with our presentations with David Levy, David Eicher, Deepti Gautam from Nepal just gave a great presentation. And up next is Adrian Bradley, who, as I mentioned before we went to break, has some new images to show. And so we're very excited to see those. Adrian, how you doing, man?
Well, I'm doing okay. The background represents fall colors, so I thought I'd go with that. My video is still a little slow, so I'm just gonna, I'll cut it and yeah, Epicam.
I could hear you talking, but your lips weren't moving.
Yeah, my lips
I was
weren't
like,
moving.
wow, how you
It's a new trick that I had learned.
Ventriloquist actors.
Yeah, exactly. So what I'll do, you did say new pictures, so they will be new pictures. They will be new to everyone at the Global Star Party.
Great.
So I thought I'd start with a little bit of background. I don't only do night sky photography, but I do have a few other things that I enjoy doing, like watching the Yankees lose to the Tigers. I also try my hand at a little macro photography.
Very nice.
When that comes out. And of course, something near and dear to you, Scott, bird photography, which I took this very recently.
That is beautiful.
With a an A7R4. Those pictures turned out really well. Now, while I love doing that sort of photography, it's the night photography that I love doing the most. Shooting at the moon is just one of the many things that I'll do coming back in from doing wildlife photography. The same big lens and the same camera gets pointed up at the moon if it's out, and I'll fire at it. One thing that's been happening is aurora, and in our area, especially to the north, there's been plenty of aurora that people have been chasing because we finally got a pretty good geomagnetic storm last night, and there's going to be a little bit of it tonight, but I don't think the conditions are going to be quite as favorable. On March 21st, I took a number of images of the aurora, and I can show you some of those. I went to take Milky Way photos, and I ended up shooting. So some of these are just raw out of camera aurora shots that I haven't released, and sometimes we mess up a little bit. The very first shot I took was this one, where all the stars were out of focus, but you could still see the aurora. Once you dial it in, stars are in focus. The aurora is distant but faint. When I got here, that's what I saw. And as I continued to shoot, the aurora simply got stronger and stronger. Now, this is a processed image, but it just shows you the aurora got stronger as I was going. Chances are strong, if you were out in my region in Michigan or northern Michigan, this is what you saw on the horizon last night. So this is a place in lower Michigan, on the tip of the thumb, the right hand tip of the thumb, called Point O'Bark Lighthouse Park. A great place for me to do my photography. So here are a couple of the images that I got. So I wasn't so upset about missing some of the aurora because I had a chance to shoot it March during the spring equinox, and I enjoyed my time out there just trying different things. Here we have a Milky Way Cygnus region shot with the aurora on the left and the Cygnus region. That's North American Nebula right there on the right. And all of the lakes that I'm shooting over are Lake Huron. This is a Milky Way shot that I attempted facing the other way. And this is light glow from Canada. We're facing southeast now. And there's some light glow from Canada across the this little pond called Lake Huron. And as you can see, the Milky Way is there. I can actually, in real time, show you some of the things that I do to bring it out before sending it to Photoshop. You might notice a slight change visibility happening in the Milky Way now, just using Lightroom. You know, doing some minor edits with Lightroom, and suddenly the Milky Way starts popping out, and you can see there's this is Scorpius. Now this, of course, this was 3 or 4 in the morning in March. The Milky Way rose over the horizon, and you could see as much of the core and of this part of the Milky Way region, you know, kind of laying on the horizon. This always makes a beautiful shot for those of you that want to do some Milky Way photography. This is always a beautiful shot. And there's a coat hanger. I always look for the coat hanger whenever I'm shooting. And there's also a nebula. Barnard's has called the Barnard's E. There's some remnant of that nebula here. This is Tarzed the star. And there's a dark nebula here that looks a little bit like an E. We might be able to bring that out if I do this. It didn't help too much, but it's a great visual target, as well as something to look for whenever you see a Milky Way image. One difference with shooting a sharp Milky Way versus just having it in a background, when you can start picking out objects in the Milky Way, like the lagoon here and even light from the Trifid, versus it just being a sort of a flat plane or just sort of a flat object. When you start picking out details, that's when you know you've got a detailed Milky Way and not just a you know, your back, you just don't have a background little band. I always prefer making this as detailed as possible because I think it adds to the overall picture. It's something you don't normally see. You know, even in Oklahoma, you can see some of this, but some of the details, you don't get to see some of the details, but with a good picture, you see them all. So tower started developing with the aurora, and let's move to, here's some of the pictures that I may have shown in some of the star parties prior. This was a final image after processing. This is one that I haven't shown, but beautiful image, the way that the aurora continued to dance through, and it's just it was amazing to watch. I could barely see some of the colors, but I could see the movement of the aurora as I was taking these photos. This is a little overdone with the purple. The colors are close, but when you're processing, you try and, you know, find the difference between good taste and overdoing it. And case in point here, one of my favorite shots or series of shots is this picture. This is the out of camera picture with that I took of the lighthouse and the Milky Way going over the lighthouse, and tried a couple of different angles. This is crooked. This one is one of the images that I made into a final. But, you know, there's some elegance with the out of camera shot. I mean, everything's clean here. It's a wide angle lens, so there's some distortion. But this is a clean, the way the camera saw the image, the lighthouse, and
And like
You can
I
still,
like how the Milky Way seems to be pouring out of one side of the lighthouse, you know, like a
yeah,
smoke trail or something.
absolutely. I mean, we can do a little bit of editing to bring that out. And I think, this image would be just as intriguing. Oops, not too much though. We want to, when you're making images look more realistic, don't be as heavy-handed as I am on the your image, because you don't want that. You want your sky to start getting dark, but you don't want it to, you don't want to overdo it. That is what you see, minus the fact that you got more detail here, the Milky Way. And then you do have this glow in the distance. If you don't like so much glow from light pollution, just take it out with the yellow and you'll have a little less glow. It'll look a little more like a darker area. Any color that you don't like as much, you click on it and you drop the saturation a bit, and that color, like that reddish color, should begin to go away. So if it's not a reddish color, you try orange and then see if it starts to go away a little bit. So just different ways that you can mess with your images, tweak them to your taste. And there's aurora now. Mind you, there's aurora going on to my left when I took this shot, but I took the time to take this because I'd already taken several other pictures. So just sort of going through here's, I think this is another shot that I processed and tried to make into a money shot. And as I go through this thing, it's, you look back at pictures and you go, these weren't too bad. Like this one, you see the pillars. The shot that I ended up selling was this one, when the pillars were well developed, but it was back here. I like this picture here too. This is the first time I've seen it in a while. This kind of takes you with me. Here I am taking pictures. That's my shadow. And I'm looking out and you see trees and you can see the aurora dancing. This is the park and that's Lake Huron. Straighten it up just a little bit so that the horizon's straight. And now I have something that I would send out, and this could quite easily just become another photo to share. Maybe make the make the sky a little darker and maybe take some of the purple out too. I'll have to adjust the colors a bit. We play around with that. But at any rate, that's where I'll just sort of scroll through. These were all the shots that I took and tried to make something of. Didn't always do a good job, but I think the originals are available. I can always start over. And I think like this would be a good one to start over on, because I think it's like, okay, I went crazy there. There's the original. So this is one that I could, work on.
Mm-hmm.
And then I was so jazzed up by being there that I stayed for sunrise. And then everything changes when it's and then the birds came in. So this is a neat way to kind of tie this up. Birds started flying in and I didn't have any birding camera. I was there to do night photography for sunrise. So I felt adequately unprepared. So all my birds were fuzzy, but really beautiful pre-dawn images that I was able to take. Here's two geese, and they looked toward where the sunrise was coming. I thought that was interesting, that as the animals came in, all the birds came in and they started looking toward the east as if they were ready to watch the sunrise themselves. So I found that to be very, very interesting. And these are the first vestiges of dawn. And I tried to get a little bit of, see the disk of the sun. The sun came up very, very fast when this happened. When the sun appeared, 6 shots later, most of the disk of the sun is already above the horizon. That was incredible to me. And so I watched it. I took pictures. I handheld most of the pictures. Another photographer had come out, and so he was taking pictures of the sunrise. Here we have more of the sunrise happening. This was one of the photos that I took. Another one. And then I tried to get, before I ended, I tried to get fancy with my sunrise photography, and finally ended up with this shot. And that will be the shot that I leave you with, as I don't know where my video is. Yep, I'm still behind, but yeah, and that's where I leave it. A night of shooting at auroras and then daytime photography or sunrise photography on top of it. I highly recommend it for all of you that aspire to get out there and take photos and try and get some images done. Going out there and just do it. If nothing else, you'll have memories. You may find a few shots that you're surprised that you had, and a few shots that you might work on and say, you know, this would be a beautiful shot to post. So that's it, Scott. And yes, I was
Very
wearing.
inspiring. That's great.
Thank you. And yes, this is a bowling shirt. You wanted to see a bowling shirt last time? That is a bowling shirt. So
I was looking for something a little bit more retro, like from the 50s or something. You know?
Yeah, I think that's being washed. I have one that's like that, but it's being washed or it's hung up somewhere. So yep. Thank you all for the comments. I saw a couple pictures of the comments. Harold Locke has seen my cranes photo, and
that's an amazing shot. It really is.
I don't know, Scott, I have an A7R4, and that was I was testing it out there, lower lighting conditions, and I'm like, well, these shots shouldn't come out so well. But when I took the picture and processed it, it turned out great.
Yeah,
so maybe there is something to the megapixels in a camera or something like that, because I've taken similar photos with my other gear and not come out with a sandhill crane shot like that. So I don't know, maybe there is something to the better cameras.
Remarkable. It is, especially in low light. So
so that camera's next thing it's gonna do is go out to that same site, and we're gonna take some night photography with it and see what I can do.
Sure.
So
I think that's the camera I'm going to try to get, is one of the Sony A7 cameras. So looking forward.
It's a great camera. It's got a number of features. So I may have an A7 III used on sale for you pretty soon if I just decide that this other one's going to be my main camera. But I didn't show wedding photos because I also will do weddings from time to time and sell prints. So, and I have a business card. I don't know that this is going to work because I'm so far behind. So, never mind. But I do have a business card now. So it's one of the photos that you saw in the presentation is the image in front of the business card. It's one of the lighthouse with the aurora behind it.
Okay.
I took
that signature image for you.
Yeah.
Right.
that it almost was the Milky Way with the lighthouse in front. I almost think that's just his signature and image. But the aurora, especially with the aurora being in season, I thought that'd be a good one to use. There's enough dark spots to put name and information in. So that's how I did it. Let's see if I think I'm only behind by a couple of seconds. So in a minute, you're going to see me hold up a business card.
Okay, well,
it's like seeing it's
hang in there.
Yeah, time and space. It's like watching me in the past.
Right.
And
astronomers are used to that.
Yeah. Yeah, I predict that I'll be holding up a business card in I don't know how many seconds. If it takes too long, I'm just going to give up. And then we can go ahead and move to the next move to your presentation.
Sure.
In fact, let's do that because I'm interested.
Right. Well, while we were talking and chatting and presenting, Jeff Wise sent me an image of the Pelican Nebula, and I thought I would share that with you. I've got some of the image data, and let's bring that up so they can see it full screen.
Yep, I can see it on your screen.
Yeah, there we go.
Yeah.
That is a beautiful image. This is 17.36 hours of integration from Jeff Wise. It's the Pelican Nebula V2 version 2, I guess. So it was 432 5-minute images with 152 millimeter telescope and ASI 6200 Pro, and he was using 3 nanometer chroma filters for this, shooting in narrowband. So it's just remarkable, but you can see all the, these tendrils here, it's like newborn stars, that pop out like seeds, Yeah. I envision that, and you can see them all over the place here. So this is a wonderful star forming region, and a very large, swath of sky. So, but excellent focus, excellent tracking, excellent processing. So great job, Jeff. A big shout out for you, dude. So, all right. So let's go back to me. I don't do very many presentations really, but in my experience and, being with amateur astronomers, doing star parties, doing global star parties like this, my history and really being involved full time in some aspect of, maybe more the serious side of amateur astronomy. That goes back to about 1980. I have just had the most amazing, experiences. The people, the places I've gone, the eclipses I've seen, all of this stuff. I'm every time that there's some other experience that happens, I go, well, that's got to be the pinnacle experience for me. I thought that when I saw the comet Shoemaker-Levy hit Jupiter, and then I thought it when I went to the eclipse while I was at Mauna Kea, and being there with professional astronomers and all the rest of it. I remember just kind of pinching myself, going, how is it that I'm even here? And meeting Buzz Aldrin, for example, and being giving moon gazing parties for him, and having a time to sit down with him privately while he told me his vision for going to Mars. Astronomy, the experience of amateur astronomy has exceeded my wildest dreams, and so I've given a lot of thought to the different aspects of astronomy. One of the things I love to do is educational outreach. I've said it before in these programs, but when things aren't right in the world for me, for whatever reason, we all run through some sort of hardship or whatever. We think that things are so heavy on us for the moment. One of the things that I do is I love to do sidewalk astronomy and show other people, the moon or Saturn for the very first time. And man, that just brings back so much energy for me that I love it. So, I talk to other people to try to kind of coach them into understanding the universe that they live in and their connection with the universe. And so I have a PowerPoint here that I have started to put together, and I'll just kind of share some of the ideas that I have. And probably you out there watching have similar ideas, similar feelings, but I'll kind of go through this. So let's do that. I'll bring this up in full presentation mode. And I call this the power of stargazing. Let me make sure that that's broadcasting right. There we go. It is. And, I feel that stargazers, whether it's just you're doing stargazing from your own backyard looking up, or if you have a telescope and you're really exploring the skies with your telescope, or you're a professional astronomer, you are developing and deepening a relationship with the stars, which I personally believe is actually good for you. And so this is one of my, everybody has heroes. I have many. A lot of them appear on Global Star Party, but one of them also is Kip Thorne, who I got to meet during the 2019 eclipse, total eclipse down in Chile. And a great, quote that he has is that we're all born with a curiosity about the universe. And those people who don't have a curiosity don't have it because it's gotten beaten out of them in some way. So, but it's absolutely true. And of course, Kip Thorne is, was a peer of Stephen Hawking, good friends with Stephen Hawking. And he is one of the Nobel laureates as one of the developers of the LIGO gravity wave detector. Let's see. There we go. So I think that one of the things that happens when you do stargazing, if you slow down a little bit, you start this kind of bonding process, that happens. This really helps if you have someone that is there to kind of guide you through the sky, and will, a lot of people who are just starting to go observing or stargazing, if they don't know you, they kind of have their persona that they kind of project to the rest of the world. But if you're out there with them and you show them the sky, which is, in a beautiful dark sky, is it's kind of like a temple. I mean, it's awe-inspiring. It feels sacred, okay? And, if you allow yourself, or if you can get someone else that you're trying to share this experience with, to kind of slow down, okay? And to really kind of drink in this sight of the Milky Way, and have them continually looking up. They're going to see meteor falls. They're going to see, they're going to start to see the sky deeper and deeper because their eyes are becoming accustomed to the dark. And they start to ask questions like, they'll say, Scott, I want to ask you a stupid question. When I hear that, I know that now that they are starting to really explore. Okay, and these experiences really, I wrote here that when you develop a relationship with the universe through stargazing and studying current astronomical science, it can lead you to greater scientific literacy. What does that mean? Okay, well, it just means that you get to gain a greater understanding into the exploration that's currently going on. Okay, and there's many different ways that scientists are exploring it. Average people are exploring it. You know, it is something I think that is inherent in our psyche and in our in our spirit to discover and explore and be curious about the world. And so this kind of these moments, I think, bring about a tranquility. You know, we've chatted about this in our chats on Global Star Parties and other programs that we've done. But many of you come forward to talk about the kind of peacefulness that kind of comes over you and the tranquility that you experience, because you're getting this sense of wonder. You're seeing, you know that you're seeing something that is much, much bigger than you are, or the city that you live in, or your job, or all of these things. You know, you start to feel this experience of feeling very tiny. But this kind of tranquility, moments of tranquility, can stave off illness, gives you better mental health, physical health, and you can start to connect yourself with everything that is. And that sense of belonging is very important to everyone. This slide I titled Mindful Communion. A quiet night of mindful communion under the stars reduces stress and improves their mood. Now, what do I mean by mindful communion? It's basically that you're now fully focused on the site that you have at hand and your exploration that's going on. Kind of reduced is all the rest of the noise of maybe some problems that you have, or things you got to do, or all these other things. Okay. You are bonding with the universe that's in front of you, and the mindfulness is that you're paying attention, okay, at that time. And this further, these are aspects of meditation, you know, and I think that astronomers, especially amateur astronomers, kind of meditate when they're looking at the sky, whether they call it meditation or not. Those moments where they're taking long looks through the telescope. Maybe stretched out on my friends get anti-gravity chairs and pairs of binoculars to look up at the sky. But it really kind of starts to soak in the sacred kind of feeling. This is very equivalent to people who go out into forests and do I think they call it forest bathing or something, where you're going out amongst the trees and stuff, and suddenly you start to just kind of notice that your senses are elevated, your mind is clearer, things look more vivid to you, and people that measure these kinds of things in health find that your blood pressure goes down. Your stress-related hormones, get reduced. This is really good stuff for you, okay? By doing this more often, you're definitely going to be healthier than you would be otherwise.
I can attest to that. After the Okie-Tex Star Party, I came home and found that I could fit in a pair of pants that I could not fit in when I left. So what Scott's saying is real. And the diet of more veggies and groceries to save on food costs might have helped just a little bit, but being out there among all those stars, seeing those skies, very therapeutic. We could watch my blood pressure, because we had a blood pressure machine there. My blood pressure went down by a few points each night while we were out.
Oh, it's
very true.
I have a blood pressure machine too. I should take it out and test it on some people. Took them out to look at an amazing sky, and so there's another aspect that is very beneficial for people, and it is the feeling of gratitude. There's a very funny talk by George Carlin, who says that he worships the sun. Okay. He goes on his rant about religion, but he worships the sun. He says, the sun is there. The sun provides for everything, and all the stuff that he's saying in his comedy routine are actually true. Okay. Without the sun, there would be no life on Earth. So it's some of these aspects of, our sun is just, one of hundreds of billions or maybe a trillion stars in the Milky Way. But it's just the right size. It's the right distance, its stability is very important to us because it needs to be stable. Even though we see it burp from time to time and, maybe it takes out a bunch of electronics or something, these conditions of us living the right distance on a planet like ours, in this totally, Goldilocks zone, is something that you should, from time to time, contemplate, okay? Yeah, maybe you didn't get that raise at work, or somebody said something you didn't like, or these kinds of things, but how often do you think about, just the basic gratitude of, the fact that you're alive, all the wonderful things that have happened to you since you were born. All of these things are because, we have this relationship with our sun and in our universe. And so it is something to kind of slow yourself down and start to think about it. And you will know that gratitude is becoming beneficial for you, because what will happen at one point is you start to find more and more things to be grateful for, okay? Versus you being irritated, okay? And getting more and more irritated. So you'll find that by doing something beneficial, like focusing on gratitude on these things, and in astronomy, we can see these things, we can understand these things, as astronomers, that the sun, the reason why, this fusion reactor that's keeping us all alive and is really something that is nothing short of miraculous. And so it is, this feeling of gratitude does, again, give you qualities that improve your health, your state of mind, okay? Being irritated all the time is really bad for you, and scientists are starting to understand why, because it kind of starts to destroy things going on, physically in your brain, in your nerves, okay? So you can stave off things like strokes and heart attacks and cancer and stuff by developing some of these really beneficial qualities. One of the things I also find is very, very interesting, I've had a chance to talk to astronauts, a few of them, and I've read about this, and this thing called the overview effect. And this really got put to light from the Apollo astronauts when they got to see, as they're coming around the far side of the moon, and they see the Earth rise. And that they suddenly look at the Earth as this living orb. They don't see the countries and the boundaries and all the rest of it. They just see this living thing out there amongst this vastness of dark space. And they know that that's their home, and they know that they are connected to it. They're part of it, okay? And almost all of those astronauts, their lives fundamentally changed. The way that they think about the Earth is just an amazing thing. And so if you can find things on the internet or books where these astronauts have described the overview effect, I recommend that you read them. Amateur astronomers also experience the overview effect by looking at other worlds through their telescopes. And I would say that one of those worlds that probably has changed more amateur astronomers than anything has been Saturn. To see Saturn in its rings and all of its beauty, and then to gaze there for long enough to see that it's got moons and that it's this beautiful treasure that's up in the sky, has really changed many people. And so it gives you, it has this benefit of reframing things for you. The stress, the everyday stress in our jobs and our responsibilities, hardships that we might think that we might have, okay, whether you do have a hardship or not, okay, they get reframed. And this is like an elixir, okay, that costs almost nothing. It's amazing. And so this reframing, I try to put down more words here, and I call it a fresh perspective. And I have the photo for me that really, hits home on this aspect is the pale blue dot photo that Carl Sagan had. The Voyager team turn the Voyager spacecraft around so that it could get this image. At the time he was trying to do this, the rest of the scientists said, look, Carl, there is no scientific value to this, okay? But I will tell you that this image of the pale blue dot, Earth from all this distance away from the Voyager spacecraft as it's heading towards the outer part of our solar system, it caused him to write his thoughts about the pale blue dot. And he discusses our centrist view of the universe, and our the greed and the wars fought, and he goes on to talk about every lover and every rock star and every memory that there ever was in all of humanity is on 2 pixels in the middle of that image, okay? And so if this doesn't, seeing something like this and bringing yourself to understand your place in the universe. I mean, if this doesn't make you feel small, okay, then I would say that you need to look again. Feeling small is something that a lot of beginner amateur astronomers experience when they're first looking through the telescope, and they see, you're pointing the telescope at maybe, I don't know, like the Whirlpool galaxy, and you tell them it's 25 million light years away. You're seeing 25 million years back into time. When we were as amateurs looking at the Whirlpool galaxy and seeing a supernova explosion, it shined brighter than the whole galaxy. And to know that explosion happened 25 million years ago, and you're just now getting the photons. It's not fake, okay? These photons aren't like dead photons or something. It's the original photons being released from that supernova, finally getting to you, finally hitting your retina. It's actual contact, okay, to those nerve endings in your eyes. And that's what visual, the visual experience is like for amateur astronomers. When I'm talking to groups of people about that, we're spaced a few feet apart, I remind them, okay, yeah, you're looking at the Whirlpool galaxy. It's 25 million light years away. A star exploded there. That star's no longer there, okay? That star's no longer there. You're seeing the explosion now, okay? And it happened 25 million years ago. And then I remind them, look, you see me and I see you, but we don't even see each other in real time. I'm seeing you the briefest fraction of a second ago, because light has to go from me to you. So these things, these aspects of that you're confronted with in amateur astronomy give you pause to reframe and think a different way, and it opens your mind to new possibilities, that the world is not so hard-edged as you think, that it is, that all of every part of what you might see as solid or gaseous or liquid, or what you think is space, okay, is all interconnected. It's all interconnected. So there's no separateness. But when you contemplate your size in the universe as being so small, that's a very humbling thing. And it's good to be humbled, okay? But I remind them, I say, look, what you know of the universe now and what you see throughout the sky, it shows you the vastness of your own mind. And so that, because it requires a mind to understand the universe, it requires our senses. And so there's lots of philosophical comments from greater thinkers than, of course, me, that have explored this. And but it gives you a practical way of taking your problems and putting them into perspective. Okay, because we're only alive for, maybe we live 100 years, but that's a short time. Okay. And so there's lots of important things that we got to do with that time. And you don't want to waste it by worrying, and you don't want to waste it by being irritated, and you don't want to waste it by making yourself not feel good, which will lead you to getting sick. So, there's lots of really cool visualizations, lots of great things that have been done for, in professional astronomers trying to do outreach and showing us images like this one. This is showing a visualization of what scientists currently think that the Milky Way galaxy looks like. You'll see this model change, as the years go by, because they're collecting more data and they're measuring our galaxy better and better all the time. But you can see where the sun is. We're out on what's called the Orion Spur. They think that that the sun is whipping around the center of the Milky Way at about 500,000 miles per hour, something on that order. And this galaxy's flying towards the Andromeda galaxy at about 1.5 million miles per hour. So we're in a new part of space that we've never been to all the time. And we're flying around on this little blue spaceship called Earth. And we've got this incredible blanket of atmosphere and the magnetic field around our planet that protects us against asteroids and all kinds of stuff, debris that's in space. Okay. So it's an amazing thing. If somebody was to write the story of this, it would just be the most fantastical explanation if you had to explain it to people that didn't know what Earth was, or didn't, let's pick aliens or whatever, how you're going to explain what Earth is to another life form. It would be a big challenge, actually. But I like to take data like this to, again, further deepen the perspective. Okay, that this is your home. Okay, your home's not just your condo or your house or your state or something that you belong to. Okay, you belong also to this, our Milky Way galaxy, and it is. It's an incredible thing in itself, and other galaxies were only discovered, quite recently. 1923, when Edwin Hubbell had found a Cepheid variable in the Andromeda galaxy, confirming suspicion that a lot of people had that these spiral nebula out there were actually other galaxies. There's the wonder of creation, okay? When people look through telescopes, they're out with you under all of this, and this kind of, this new perspective is coming about, and they're starting to ask other questions. They'll ask things like, whether they're coming from a religious side or their own sacred feelings that they might have, or just, from a straight up, as a scientist might just characterize it, chemical reactions and energy and stuff. But there's this whole cycle of creation is really, really interesting. And amateur astronomers can see this by looking at star forming regions, like the shot that we saw earlier with Jeff Wise, showing those tendrils of dark nebulosity compressing down, fusions occurring, making new stars, new planets and stuff. And so this really nice illustration here shows, how a, sun-like star goes through a star, is coming from a star-forming nebula, goes to the red giant stage, becomes a planetary nebula, becomes a white dwarf. This other material, you can see like two little arcs here, that kind of arcing off there. They return back to these giant clouds of hydrogen and dust, which are the beautiful nebula that we see, like M42 or the Pelican Nebula that we just looked at. In that star-making factory, are little stars like the sun, even smaller stars than the sun, but also some massive stars. And so that life cycle also we see. I saw a massive star death in the Whirlpool Galaxy. A giant star exploded, causing a supernova, which could become a neutron star at the end of it, or a black hole. One of the strangest things ever. And I would say that we are living in this amazing renaissance, or this golden era of astronomy, because something that when I was a kid in the 1960s, a black hole was just it was like science fiction. No one had seen a black hole. There were thoughts about black holes, but it had not been totally worked out. And then just last couple of years or so, scientists have actually finally imaged a black hole, which is just mind-blowing. But that means, this whole process doesn't mean that you're somehow separate from it, because all the elements that are forged in stars in this whole process are the elements that make up us, So you'll hear amateur astronomers say, kind of tongue in cheek, well, we're made of stardust, but it's absolutely true. The iron in your blood was, from a supernova explosion. Every element that's in our bodies, if you reduced a human body to its chemical elements, which you could do, all of these chemical elements were formed in stars. So, you have this very innate connection. You are hardwired to the universe. And this is another aspect of looking at, contemplating the universe and stuff, and all of its benefits that I just mentioned, is something that you should do. Now, again, this doesn't mean that you have to go to an incredibly dark site. You could be in the middle of the city. You could live in Las Vegas or New York City, London, wherever you are on this planet. But you can still see stars, and you can still see our moon, and you can still see planets, and of course you can still see our sun. And so I love this quote from Stephen Hawking about remembering to look up at the stars. He says, look at the stars and now down at your feet, and try to make sense of what you see and wonder about that, of what makes the universe exist. Be curious, and however difficult life may seem. And I will tell you that I met Stephen Hawking briefly at Caltech, and to see really face to face how that his disease had disabled him, and I tried to put myself into his shoes and think about being as disabled as he was. Yet, his mind was able to convey amazing secrets, and I think that he even, in his life story, talked about how his so-called disability is really what allowed him to think the thoughts that he was able to think, and to work out the problems that he was able to work out. So, a real genius that could take the most complex concepts of the universe, like explaining the inner properties of a black hole, and to make it so that anyone could understand it, is really the mark of a genius. He said, there's always something you can do and succeed at, and it matters that you just don't give up. And so that's an important piece of advice, I think, for anyone. So anyways, that's kind of those are my thoughts. And, I want to thank you for letting me give that little presentation. Let's see if I can get rid of this. Here we go. And so I think that's kind of where we're at right now. And it looks like we have some people here for the after party.
Yeah, my video is still caught in the time warp, so we're just gonna let that. It's gonna play out in the
César and
background.
Maxi, how are you? Maxi, how do you feel, man?
Well, I'm still recovering.
You're
My
still
voice
recovering.
is very loud.
Yeah.
But I'm still coughing. I have last week from the temperature of here was very hot, and with the air conditioner and everything changing a lot. Well, I get a flu normally, but well, I'm now recovering for that. Well, César, no, last Saturday how it was.
Yes, we had 35 degrees centigrade in springtime, and was a nightmare because we don't expected a so high temperatures in the end of the springtime. Well, and today is not well. The last week was or Monday was coming a cold weather again, but today is warm again, and this makes I understand you that that you are in a trouble. Yes, I understand. It's a mix of different temperatures.
Drinking 3 kinds of pills, for the fever, from my nose, but I'm still recovering. But I'm here.
You gotta take care of yourself. I'm just glad it's not super serious or not.
No,
any
of course.
worse.
Started with
my video finally caught up to this to the underneath a second at least. So now my video's back, which means I can.
You don't have
that we see the
delay.
fall colors. We can switch back to we can go back to a space virtual background. There we go.
Yeah. I don't have this possibility with my notebook to make a virtual background. This is my real background, and this is my living room. And first of all, this line, orange and blue, are something like decoration from the last Halloween party in my apartment from my daughter. And anybody remove the last? Yes. And here in my screen, without sound, of course, is yeah.
Let's see how long it takes for all our hands to go up.
Many times I enjoyed in my living room the show.
There you go. That's what my video was like earlier.
Yeah. Yes. Well, I started
waited about 10
your
seconds.
Pictures. Absolutely. And I enjoyed a lot your pictures in the TV because they are wonderful. The show
lighthouse
looks very
yeah.
The show looks very good. Really with very high definition. It's something that is amazing. It's nice to see. Well, tonight I had Scott knows that why I'm early, not early, sorry, late. Because
this is the late night show from the GSP.
That's right.
Well, this is the late show. Yes, I was able only for the late show of because was impossible early to connect. Well, but all is resolved, Scott, about the accident of my wife in her toe. It's okay now. And well, I said, okay, I need to go to connect a little in the end of the show. For the next week, I prepare again the presentation that it's about resolution power, but with pictures of the planets comparing with the same scene conditions, pictures of Jupiter with different telescope. The idea it's complete one or two or three pictures more because I found exactly the size, the angular size of the details over Jupiter to compare the real things about the resolution powers in optics, comparing the same quality optics and the limits of the aperture only. It's very interesting because this was the thing that was today impossible to present for me, but it's great to show and experiment the idea about the possibilities and how Jupiter is an excellent field of experiment to know resolution. Of course, that double star are too, but it's so easy to understood with the different storm and the smallest storms and details in Jupiter. And when you compare, for example, the Explorer Scientific 127 Maxutov, it's really in their own limit of the diffracting, the diffraction. Sorry. I was read again Texero books, amateur telescope making books. Was that was the Bible. I promise that next week I present that about resolution, and of course that I'm able all time to talk about optics. And it's very interesting was very interesting for me. Return to the books.
Yes. Yeah, I don't know if Adrian, if you ever got into telescope making or read any of the Texero books, but they were, and I think there still are, some of the best books there are for making a telescope and testing a mirror and all the rest of it. Of course, César is very much into that and has been making mirrors for, I think, since he was very young.
I come in a minute. I want to show you something.
Okay.
Okay. And yeah, the club that I'm in, a lot of guys there, the older guys did build their own telescopes, and some may have used that book.
Yeah.
So telescope building was just a way of life, and it's given way to these huge astrophotography setups now. It's almost taking over the hobby to the point where people are getting in it, getting these impressive rigs, and then turning around and shooting M42, shooting trying to think of the Iris Nebula has become a popular target. And that looks like Maxi, what do you got? That looks like a homemade OTA.
Exactly, but this is a galvanized tube.
Yeah.
From very thin that I think 2 years ago I bought only the mirrors because I don't know how to polish, but I wonder, well, let's see if I can do some Newtonian. So basically it's like more like a Frankenstein style of
a pipe
tube. Yes,
Yes, you
The,
stole a pipe tube from another house, from the
no,
neighbor.
I bought it. I bought it.
Ah, okay.
Put it in the
If not,
basement.
160
if
pesos.
not, it's
You said it
okay.
was in the basement. You said this make a good telescope.
160 pesos. Hey,
There's
great.
Well,
Oh, yeah.
it's not very circular because this support is not very measured, but in the other place,
Okay.
I have
okay.
this place to get the mirror and three. Well, we call it here mariposas. Three. I don't know how it calls to move. Well,
adjustment screws.
the adjustment
is
to
what we call
the
them.
to the primary mirror that I
So you can
also
collimate.
made the support of that mirror with only parts of a lamp, a lámpara.
Great.
You used what you
A
had.
lamp, yeah.
A lamp, and the cup where is the secondary mirror, you can see there. There is the camera.
Yes, and this is collimated. Actually, yeah.
Oh, no, but
something that is great in
the cup.
Yeah, it's a 4.5 inches.
You can still get a good view.
140. Yes.
You still get a good view of 47 Tucane with that telescope.
I tried. Well, you can see the holes.
There's the hole for the secondary.
The focuser. I put it out, but I measured how was the focal distance with pointing to the moon, and with the regla I was measuring and see that when I bought it, it says that it was 500 millimeters, but it was 41 4010 no 400
4010
no
410
millimeters of focal length. So I had another OTA, but I had to cut it. So that's why I built this, and you can see the other host practicing the focal, and then there is where it is put it, so to get focus. You know,
I love that.
The mirrors are okay. I only buy it, I don't know, $10.
I remember that you told me that that you buy that of maybe of an old telescope, and this is crazy, but this every time this work. Let me show you my Bible.
Yeah. Now César, I looked that book up on Amazon, and you can buy that book used book because it's not published anymore. Well, they say 5 new for $80. Okay, but this one's hardcover.
And I love that, guys.
$118. Wilman Bell. Well, they're not.
Yeah.
They're not.
Yes. They don't exist anymore, I think. And this is something like the parabola of Jesus. No, this is the real problem of astronomy, and this is our fundament of life. In our religion. Yes, the spheric correction. Yes, when Scott designed something in opticals, he had nightmares with the spherical.
I have nightmares. That's right.
Absolutely. Yes.
Things like astigmatism and spherical aberrations and
down
edge and
yes, and I
optics
finished
are not easy.
Yes, it's terrible, and I finished it. We bought for this week a new metal latte torno. How do you say latte? I don't know how the machine is the name lathe.
In
lathe. Yes, the
yeah,
machine
English it's
to
lathe.
yes.
Yeah.
We have a new
Turner,
one to
turning.
yes, yes. We have a new one. We need to because I have for to work in make the domes or make metal parts or focusers and another craziness. Um,
3D
outside the
printing might
laboratory of the optic,
you
we
might
have
be using 3D printing for
a
most of that nowadays.
very small manufacturing area. Yeah, yes. I'm start to return to make some pieces for to make some experiments and we can retake some projects because I like to every time I make I love to make
Something
optical
new.
surface,
Oh.
yes, and something that we are very excited to receive the new telescope, National Geographic telescopes, because from Explore Scientific, maybe you know Scott this brand, and
I've heard of it.
Heard of it.
yeah, yes, without a quantity of Explore Scientific telescope, and this is something that we choose a very small focal distance, very short, with the idea, you know, for it's one of my favorites size of in the 4.5 inches mirror. We know that only Explore Scientific have or Bresser or Jingwa Optical or Hotech, or how do you say this manufacturing, only they have the technology to make a very narrow parabol, because you need really in this short focal short, the focal razor is 5, I think, or 4.7, and we have mirrors from the past from Jingwa Optical Company that we take a measure with the Foucault, and they know how to make really parabolic mirror, and really the difference between the sphere and the parabol is really interesting, but really it's an important size. For us, have again this kind of telescope. It's a first level telescope. For maybe you saw with Living the Stars, she made a unbox of the telescope. It's very easy, very short tube. We are really excited to have this kind of telescope, like a first telescope for Christmas or for the kids, instead the very small or refractors, and you have the opportunity to have like first telescope for a gift for a kid, a telescope that have the same very short razor focal like Maxi shows. And this is great because you can put planetarium camera with today many planetarium cameras like Sibony 3305 or CWBO 2024 have the Sony 290 sensor that work really fast with this kind of focal length. And this is great because the idea is push to the people to make astrophotography in a shortest time of maybe, and at the lower age that that ever was impossible to to make, sorry. And this is very interesting. And this is all about optics. Is really the power of the optics, because the telescope is very easy. It's a tripod. It's an azimuth mount. I can show you your video, and I say just say to Maxi and Adrian that Levy have a video unboxing this telescope, the National Geographic Telescope, Scott.
Ah, nice.
It's very educational because you have maybe 19 magnification from 19 to 120, and the people sometimes say only 19 times, and we say yes, it's great because it's
Sure.
you have a very wide field of view.
Oh, yeah.
And you can understand where the things are, and you can see everything in this part of the sky.
Right. Yeah, many people that think about telescopes think, especially beginners, they think of it as just as a magnification machine, right? They don't understand the real power is the light gathering power and the resolving power, you know?
Yes, absolutely. And now it's not, actually it's not how the first level telescope or department store telescope are selling, but in the 90s, in the first time of the 18th, the telescope put in their boxes 1,000 powers.
Yes, I
remember. Yeah, yes.
When I'm a child,
Oh, yeah.
Yeah, that's illegal.
Yes.
Now. That's illegal in some countries to do that kind of.
Yeah, it was how you sold telescope.
Yeah, that's how you sold toy telescopes, anyways.
Yeah, you didn't explain the
Absolutely.
fact that you wouldn't be able to see anything at all.
Nothing.
But it's 1,000 power. Yeah, it's can't focus, but it's 1,000 power.
Yeah,
that blob is
absolutely,
Jupiter.
yeah.
Just deal with it.
Just deal.
And you shoot at the moon and you can barely see craters, but it's 1,000 power.
See the Martians. Yeah.
Yeah, you could your imagination will fill in all of the details.
Yeah.
Whatever you
Looking over the shoulder of the
can
Martian,
you can claim
Yeah.
this.
What book he's reading, right?
Absolutely. Come on. I remember how many times I removed the solar filter from the boxes and put in the trash because
yeah.
I start yes we
Terrible.
started importing in 1990. Oh my God! In only 5 days more, I'll be get 30 years in Saraco company. This is crazy. Because I start to remember that we start to import. I am optician, especially, but my specialization from my teenage time, and I'm studied the part of instrumental opticals in my secondary and my technical improvements. And when we start to receive the telescope from the importation from Japan, we only me understood the things about optics, instruments. And I say, what is this solar filter? For what? To put in the eyepiece? It's crazy.
For it to explode in the eyepiece and blind you.
Absolutely.
If you don't want,
I remove
if
that.
you're tired of seeing things in the world, try this
Yeah.
solar eyepiece and see if you can find
And
the corona of the sun.
Sure. And the people told me, where is the solar filter? No, I'm sorry. I put in the trash. I don't sell you with that. Because it's forbidden. Yeah.
Yeah, I wouldn't want your eyesight. I wouldn't want one of your eyes to get a permanent burn. I almost had that happen. I had a solar filter that was starting to come apart. I'm looking at the sun through the filter, and all of a sudden the light just starts to get bright. And I go, this isn't what's going on. And I pull my eyes away because I'm like, wait, it felt like the eyes were beginning to get shot up with the lasers. I looked and I saw that the filter material had begun peeling off of the side.
Oh my God.
So
No,
half
my.
of the
I really got to check. You know?
yeah, I think I think it's gone now. It's no longer, but one side of the sun was still blocked. You could still see the one side, and the other side was just blinding, it becoming blinding. And I pulled it's like I had to realize what was going on. Something's wrong. Pull the eye away.
Yeah.
And then I look up and I realized that's because the filter.
And you were lucky, Adrian.
Yeah, I think I had just
Usually you
taken
don't
a
have
photo.
that. Even if you try to pull away, it's already too late, you know? So.
Yeah, it was, something's going wrong. I probably pulled away in under a second, but I just remember the whole thing as if it was happening in slow motion.
Oh my God.
You know, I did an experiment when I bought a better solar filter to the Maxo, and I think I told a few months ago, but it's very good to remind it because it's very dangerous to put your eye. You know, I was trying to do some sunspots. I don't remember, it was in April, and well, I was getting heating because I was outside and tried to with the cell phone and everything. No, sorry, not with the cell phone, with the webcam. First of it was, and you know, I gave up. I turned off the computer and everything, but I don't know. I removed the solar filter. I don't know. It was, but I didn't realize it was still pointing to the sun. And when I go, I put out the camera. I put off and then start to get smoked.
Yes.
Yeah.
Oh, geez. I put the tape inside of the scope because I thought that I was, pointing to another place or turning off the mount. But
you had
no,
great,
it was
you
still...
had great solar tracking. Unfortunately, for
yeah,
it was too good.
The camera survived, but it burned a little plastic.
The plastic, yes, and the borders, maybe, yes, absolutely.
Well,
and
it was
you
a
don't
few
have
seconds,
an
maybe
idea.
3
seconds. Absolutely, Maxi. You don't have an idea that how many eyepieces I need to repair from our customers. Then they don't tell me the truth that they point to the sun. And they say, I don't know.
I guess that's why the
crosshair borders of the eyepieces or blow up the glass, because sometimes the field lenses of the eyepiece explode with the heat.
Yeah.
Yes.
Astronomy
Sorry, Adrian,
gone
that
very, very wrong. That's okay. But it's like your story describes why the Astronomical League has to say in bold letters, please do not look at the sun.
Absolutely.
And it's, during the solar eclipse, a lot of people wouldn't look at it when the moon covered it. And I didn't blame them. I was kind of glad for those folks that I ended up getting a view of it on my iPhone with an adapter as my telescope was tracking it. So I just hit record for my iPhone, and people were watching that instead of the actual event. They were looking down on my iPhone and watching it because they felt it was a safer thing. And I said, that's fine. So there's a growing crowd of folks trying to peer in to look at the phone, which I don't have, trying to look at a phone's picture. And I'm looking up, or I'm looking at, just trying different things. The one thing I didn't do was use binoculars. We're going to fix that for this. In 2024, there will be a pair of binoculars with me. And I may just handhold a couple of the shots and just to say I have it, and just try and look and enjoy. Or if I decide to, I'll set something up to work automatically and enjoy the eclipse while the gear is
If you can
busy
do
taking
that,
shots.
Adrian, I would definitely recommend that because many people who photograph an eclipse miss the whole experience of it, because they're focused on the gear and changing,
Yeah.
moving filters and putting filters on. And
Lenses.
this.
I only
Yeah.
I arm two equipments, the Newtonian with the AQ5 and then the Maxi to try to do with the cell phone and a little mount. And when well, first of all, I put the camera to the Newtonian and everything and point to the sun. Okay, it's start to move it. But when I finished the another mount, I realized, oh my God, it's starting the sun eclipse. O sea, it was the very orange ball and starting. I want to do all the clips. And now I say, okay, I forget it.
Forget that.
That's it.
Yeah, I had
That's-
punted. Yeah, I had punted on the plan to record because I thought I was gonna miss it. It looked like I'd knocked the telescope offline, but then as I look up and I look back down on my phone, and there it is, the image of the eclipse, and I go, oh, I got it. I didn't think I was gonna have it. I started recording, and I recorded all of us screaming like crazy, just screaming in the exclamations, the oh my god. It depends. So it's I'm trying to fashion this. Yeah, I'm trying to fashion this into a tellable joke. The difference when you have those that are very religious and we're seeing the eclipse, you hear a lot of exclamations, oh my god. If they're not religious, you hear something else with God in it. It's coming from the same emotion.
I have heard those expletives from both sides.
Yeah, it's it almost doesn't matter. You just let
it doesn't
go.
matter. It's
it's
an amazing life-changing experience. That is,
and it pulls the real you out. It's one of those
and
things
if you
that'll
have
do it.
wind, much better.
Oh, of course. Oh.
Yeah, you've got it, to your talk, Scott, astronomy, I've counted a few things that, catch people off guard, and it's like they suddenly become themselves. Seeing Saturn for the first time.
That's right.
Makes them seeing the Milky Way when you're at a dark site and seeing that band in the sky. It's like, wow. And I heard it at Okitex. There are a lot of people going, oh, wow. And as it was getting brighter and brighter, the core of the Milky Way, and just the responses people were saying, like, wow, look at that. It was kind of shades of the eclipse. The eclipses create the wow effect, and aurora create a bit of a wow effect too. People will say, wow, look at that.
Yeah.
Some kind of way, the touchable effect, or visually effect, that then when they see that, they start to recognize what it means to the distance where you are, the perspective, and then start to understand what is all that.
It's one of the few things that I think there was probably a rise in astronomy club memberships and things, because we're going through kind of an era where you have COVID and there's a lot of people that simply don't believe. Maybe they are beginning to believe as it affects their families, but you had this tug of war back and forth between what science is and what it isn't. But all the time, astronomy has had there's a growth in astronomy. It's almost as if people were reaching for something that's real.
That's right.
You can look at the night sky and that star is there, and these objects are there, and you put it in a telescope and you demonstrate that all the telescope's doing is magnifying what you're seeing. So someone says, "Oh, that's just a picture." Well, you point the telescope, so okay, you see that leaf over there, that tree,
Right.
and now look through the telescope. It's like, oh, it just made it a lot closer. Well, we pointed at the sky. All it's doing is making that stuff a lot closer. That stuff's real too.
Sure.
And it I've had a lot of people don't you just feel small when you're looking at that? And I go, I feel like I'm a part of it. It's
That's part of the transformation, I think.
Yeah.
Places you go from this, because you've got this kind of, people walk around with this construct all the time that they think that their bills and their home and all this stuff that they see on the news and political controversies or whatever, they think that's the real world.
Yeah.
It's a tiny dot.
You can put that in, squeeze your finger and your thumb as tightly as you can. That's how small that is.
How small it is.
Absolutely.
And it's
compared to,
depending on where you are.
That's right.
Yeah, and it's awakening people up to just sort of broadening your horizons. I think you were spot on about what it does to you. Is the perspective of saying, these issues that I have will soon pass. I mean, it's like everything else.
That's right.
On the pale blue dot, and it, regardless of if you're still listening to us out there, and and you go to a church and you've explained that it's God behind all of it, or you don't. And I always kind of make the distinction. It almost doesn't matter when you look at it from the perspective. The amazing thing is that, we as a species have been able to figure out all of these things from our home planet.
Exactly.
That's we say that we're small, but yet again, we were able to do this and figure all of these things out. So we're maybe not so small if you look at it as an entire humanity thing. If you say, well, those are just scientists and things like that.
Those guys are not part of the human race, or
it's
the separateness that kind of starts to dissolve.
Yeah, we saw a lot of that. You saw flat Earth theory come back in force, and the theme that I kept hearing was NASA's lying to you is what you kept hearing. And it struck me as to say, whether that you can make up some math or make it look like you're smart to say the Earth is truly flat, it seems to me the big problem is the respect for authority has dwindled, and it's something that we need to regain. So it may not be a stretch to say, well, let's start with a sky that's unchanging and unmoving. No matter what you can say about what's up there, it comes back. It keeps repeating. There are people that can show you, that can point to something in the telescope night after night, except in Michigan where it's always cloudy. They can point to it night after night and it shows up again. And you go, okay, how far away is it? It's let's see, Orion Nebula, some 1,400 light years or 1,000 light years. I forget the exact number. It's far enough away that you can't get to it in a plane. And sometimes figuring out how to relate what's in space, what they're seeing, to their own lives, that's the challenge of outreach. I go with the zodiac sign. Some folks are interested in, their zodiac sign. And if it happens to be in the summer and you were born in November, Scorpius is up, Sagittarius. If you have a December sign, I always like pointing it out from.
It helps some people start to make the connection.
If you're 7 years old, if you're 49 years old, it's like, that's your sign right there.
Yeah.
And I've got, wow, really? And again, people become their real selves when you point something out, and it's, it's like all of a sudden you're connected with what your sign is. And it's like the stars begin to mean more.
All of you guys are, interpret the sky. interpreter has a very, very special role in kind of, helping somebody kind of cross that bridge. Okay, whether you're using astrology or, you're talking about in terms of maybe religious or, through, science or whatever. I think it's important that the interpreter is very sensitive to who they have, who they're working with, so
Absolutely.
so if I have someone that is really focused on their religion, I use that to talk about the miraculous things, and I will say, it's miraculous, and that
Yes.
resonates with them. They go, yeah, it's a miracle.
Yeah, exactly.
You
We
know?
have
So-
you have the Catholic Church that has an observatory. I think most we know
Absolutely.
of Brother Guy,
Yep.
Consolmagno, who's the head of the observatory.
Yep.
And one thing that we like to say, where our faith, may be in God for things, but we don't deny the fact that we're made of stardust.
Right.
You go to Brother Guy and he'll say that's absolutely correct. You won't hear, there are many that would just say, we were put here by God, and I'll say, well, actually your parents had a real big
They had a big role in that.
and
and the DNA and
yeah,
all
the
of things.
DNA.
But you start really getting down into it, and still scientists don't have a good explanation of what energy is. Okay, they don't know exactly what gravity is. Okay, they can tell you effects from it. Okay, but
Right.
and as we try to figure out things like the expansion of the universe and running, there's like say running the film backwards. Well, okay, if everything's expanding, it's going back down to a point, and that somehow started with the Big Bang. But what became of the Big Bang? Why did the Big Bang happen? Why these kind of things? You
all
keep
of these
asking why,
questions.
and it's you start running up against a wall, okay, of things that have not had a good explanation yet. So
Yeah, so for many it's just comforting if you feel, well, it was God, and that's the path we take. But your scientific mind says, well, I still want to know.
I still want to know.
The belief is,
Yes.
God works through physics. Then it's one of the toughest things to do, to combine, you take religion and you take science, and can both learn from each other. We still, we have a lot of sticks in the ground on both sides to do outreach to, and navigating the two can be tough, but I think it's very worthwhile, because either way, our appreciation for where we live, the home, all of the things that you had in your presentation, Scott, I mean, that it's why I think these global star parties are well attended, no matter what the background is.
Mm-hmm.
And there's César.
Bertrand Russell.
Russell. And,
right.
Yeah.
No, the most Adrian, the most fun thing is that we have a Bible, and beside the Bible is this book in my bibliothèque. My library is a mix of yes.
Yeah,
I
and
have
then
this
there's
edition
who is it?
in English and Spain too.
Yeah, and then the opposite side, there's someone that Neil deGrasse Tyson interviewed, and I forget his name, who's, they had a recent discussion about science, and now he's the opposite of God, but you can still learn. There's things you learn from that side, and it's like, this is the whole goal of all of these sides, is to understand our place. And to do that, you have to get rid of a little bit of you have to get out of your comfort zone a bit. You have to say, okay, I got out of my comfort zone. There were no stakes for 2 or 3 weeks, and the results were pretty good. Now the stakes are back, and I'm sure I'll fill more of the screen as the months come in 2022. But it's you get out of your comfort zone and you're willing to learn, then you add things, your perspective changes. If you pray, you still continue to pray, but you begin to relate to more people, relate to humanity. It's actually supposed to be it's a confessable thing to skip mass, because the commandment of being together with people, joining with people is something that the church looks for all of us to do. So
Right.
that's, you can take the just wanting to get together, and you can take what part of the reason of the revolt of with COVID all around the world is the fact that people were being asked to keep a distance. And for a lot of folks, that's just, no, it's relating to people that is so very important to the quality of life.
That's right.
And so
I
that
think
becomes the
during
issue.
COVID and this recent expansion that we've seen in membership and astronomy clubs and people being interested in what's going on, I think a lot of people were just like locked down at home, and they went into their backyards at night and they go, wow,
Yeah.
what's that?
And it provided,
they got this sacred feeling. Okay. They got this sacred feeling. All right. And so that's something very difficult to put your finger on. Okay. But it's
exactly
definitely there. Okay. And so you can understand why, that all the different religions happened. Okay. Still are going on, and it's just, they are lenses on looking on who we are, where we came from, these kinds of things. And for a lot of people, religion, formalized religion is a wonderful thing because it made their life better. They could understand how they
gave them
got
structure.
better. Okay.
Yeah.
Right. They weren't destroying themselves anymore.
Yeah.
Right. And
yeah,
so
those things gave them structure.
very
and
important.
that's
I mean,
I was
I'm all for that.
gave me
Okay.
structure too, actually. So I gave them
yes.
structure. Yeah, me too. But
Yeah.
and I think it led, a lot of things led to, looking up into the stars and getting, understanding that there's something special there, and being able to photograph it, in the context of Earth or just by itself. It's one thing with astrophotography. I see a lot of gear and a lot of look at how a lot of talking about the process, and you end up with an image like I have in my background, the Orion Nebula and the Running Man, which I had tried to get for a few years with meager equipment, and then one long 2-minute exposure and it pops out. In fact, I'll share the this image is it's a good example of just, all I did was take a 2-minute image and do some processing, and I ended up with this shot. And what I like about it, you can get a lot of beautiful renditions of this region of Orion's sword. There are a lot of beautiful renditions. What this did for me, though, was in a 2-minute time span, I was able to shoot the Orion Nebula and have it hanging out in space. I've all of this area, and there's actually more here, which a lot of people tease out in the image, and so you have all this nebulosity here. But this is hanging out in space. It's as big as this is across, light years across, and so many light years away.
Yeah.
It's still small compared to the size of the universe as a whole. It's, there's still, and then here are these streaks, which, we're looking at this from Earth, and these streaks are part of the picture. These are satellites, geosynchronous satellites, maybe a meteor here or there, depends on, if the streak is getting brighter, but like here, you've got a bunch of them. You know, the whole thing is still interconnected. We're able to peer out into space and see this, you know, with modest
incredible.
equipment.
And
So
Adrian, think that is like you took a picture from the bottom of a lake. That's our hair, our air that we breathe.
yeah,
And the satellites are boats over the surface, and this is
yeah,
the same. And the other things are so far, and it's incredible that we are in when we watch to our heads, and it's we are in the bottom of a lake that is our air, and we are watching we are watching time, especially that
yeah,
mostly we are watching a history.
That's
It's
right.
incredible because
yeah,
the
yeah.
satellites are to our they are like boats
Mhm.
sailing in the over the surface of
Yeah.
our
And
atmosphere, and
they actually
really
sailed over that
it's
surface
so magic.
about
Absolutely.
3
Something that
14,000 light years ago.
Right.
yes, this one is the satellite is
But
our
we're just now
time.
seeing
It's
the
our
light.
Now
time
getting
because
it.
it's
Just now
yes,
getting it.
yes.
Yeah. So I know
Yeah.
yeah, Scott sent our message. I am going to go ahead and take off. I enjoyed chatting. You
Thank
all are
you.
my friends.
Adrian.
Scott, I still got to ask you about the trackers from Explore Scientific. I'd
Sure.
love to pick one up and start
Sure.
imaging using it. I have no problem doing that, and I would love to
Yeah.
try it out and see what it'll do. So
Sure.
I'll hit the website
Adrian,
and see if I can find it.
I got
before you go, I want to show some pictures that I took a couple of weeks ago.
Okay.
Some place
Go ahead and
of the south.
show a couple. It is
It's
midnight,
only a
but
few.
it's 2 a.m. where you are, so it's even later for you, Maxi.
1
For
a.m.
you and Cesar.
1 a.m. It's
Oh, it's 1
early
a.m.
too.
It's 1 hour. I keep thinking it's 2. But I think we're about to enter daylight savings time again. As always, if I could recreate that picture, I would be very happy.
Very happy. Yes.
Well, sorry. This is right now here. It's the
Yeah, I
east.
saw Crux is rising.
Exactly.
Yeah, Crux is
And
rising.
Orion is really
Yeah.
Is upside
going
down.
up. Exactly.
It's upside down. Yes.
Oh, yeah,
For
that's
us,
right.
it's right side up for you. That is how Orion just is. That's how Taurus just is.
This is Sirio.
Yep.
It's upside down too.
The dog is drawn upside down.
Yeah.
But you can see Sirius and you can see Canopus not far from it.
Yes.
We can't unless
right
we
there.
go far south enough. Yep.
Seriously, Sirius is up.
Well, part of I think was before the another GSP. I was outside in my backyard and I started to practice to this southern place, and I started to be here in this particularly open cluster stars.
Oh, cool.
And this is called NGC 2547.
Beautiful.
And this is what I took.
Oh, nice.
Oh,
It
nice.
was only 10 pictures only.
That's still really nice. That's still nicely done. Look at that.
What size
Nice.
telescope was that, Maxi?
No, it was with the 8 inches and the
8-inch telescope.
and this
Yeah.
ZWO
Yeah.
533.
Very nice.
And I was trying to see and comparing with Stellarium.
I think you got most of them.
You can see these two stars above, and it was kind of there because you can see these two stars and the brightness
There's that
down
bright
there.
one way down in your frame.
So
Mhm.
basically, it's completely
you
in
nailed
this
it.
place. And well, I have too many places to practice, but I have light pollution. This is only a color camera, and I was trying to practicing with the Dolphin Head Nebula, and its size and fits really good in this with this equipment, but I only got this kind of place and gave up, and
On the
I say,
fainter.
okay, I had to try this with maybe too much hours and
Yeah.
with the farm area. So
Yeah.
I also saw this place. This is a star. This is a V341 Carina, or HIP, well, 3HH34.
Yeah.
But I saw this kind of
Oh, it's another nebulosity.
and
yeah.
I pointed, and
these are all going to be my targets when I go to Argentina.
Yeah.
Try to get these.
It wasn't very with this kind of shape, but I didn't.
You did get
the
some of
pictures.
it.
No, I didn't. I also gave up, but I want to show you
It's for the next week.
Exactly.
Yeah.
So because I have too many places to
Yeah,
practice, and then I went to this place. It's here. This is the Pen Nebula, or Pencil Nebula. It's
I've seen
a
some pictures of that.
Look at that.
It's
Yeah.
a very strange shape.
Very strange,
Yes.
and yes, and it's not easy target. But with your sky and your telescope, you can do it.
Well, I did sorry. It was this. I only did maybe.
Well, but yes, how many times, Maxi?
No, it was 10 or pictures of 3 minutes, and pollution area without filters, and
But you can
that's-
repeat. You can repeat with filter, with UHC filter, and you have more opportunity to.
Yeah,
have
probably because it's a reflection nebula. So
yes,
I can
Oh,
get
that's
some
nice.
info. And
Yeah, you got a little data out of it.
Nice.
Yeah. Look at the focus in your stars. I mean, that's just
No,
great.
yes, and maybe these guys put a Hubbell
yeah,
image,
a palette
you know.
and everything.
Come
Now,
on,
Yeah.
yes,
That's
it's
right.
not.
Yeah, but
absolutely.
you got.
Yeah.
I mean,
You got
the
something,
image,
which
the structure
is
of it. So that's
that's
I got the
absolutely.
pencil. I got some kind of the pencil.
did.
But
Yeah, that looks like a good looks like the next time, maybe next global star party, you'll have to share some of that with the with the bigger crowd.
Yeah.
Well, but
one of next weekend I can
at
go
this time,
to Chivilcoy.
Yeah.
Yeah.
Yes, definitely.
Yeah. All right.
no
Well,
problem.
gentlemen,
yes,
I am gonna have to call it.
too.
I
Yeah,
think
yes.
Scott's trying to call it.
Yes.
So Maxi, save all these. You have too many places. You must save them so we can see them. The next global star party. I
remember,
Absolutely.
next global
Interesting.
star party is about
72.
the inspiration of Carl Sagan. Okay.
So-
Excellent.
Tuesday, November 9th is his birthday.
Okay, mine was November 8th, so I was born a day before.
It's the
so I'll have
birthday,
to keep
Carl
that in mind.
Sagan birthday. Oh, excellent.
Yeah.
Well,
So we'll,
Actually, today
keep that in
is
mind.
the birthday of my fiance. So happy
All
birthday,
right,
Hannah.
so
Okay,
happy
great.
birthday to her. All these
Yes,
November
absolutely.
birthdays. All right, well, gentlemen,
right.
thank you again for
Thank
having
you
me.
for
It's
me.
an honor knowing you all.
The audience.
And,
Thank you, Scott.
Yeah.
We will do this again next global star party. I will find my
Coming
way
up
on, whether it's
very
after
soon.
bowling or not.
Yeah.
And
Okay.
All right. Thank
All
you.
righty.
everyone. Get
Thank
better,
you.
Maxi. I know that you.
Yeah, well.
Good
He's,
night to
he's
everyone.
smiling now because of the
Yeah, I
night
know.
sky and the
He's happy.
stars.
Look, he's
You're
got
right.
these beautiful
You
images.
could, yeah, you haven't heard him sniff for,
No.
the last 30
Astronomy
minutes
does make
because
you
of
better.
astronomy.
So,
Yeah, it's true.
Yeah.
So,
we saw it right here, transform right in front of our very eyes.
yep. Soon as we
Yeah.
leave, he's gonna start hacking away again.
All right,
wait,
guys.
wait, Adrian.
Wait.
Wait.
Tell
Impossible to
César
step
what
back
you
to.
told me.
Okay.
Tell César what you told me.
What did I tell you?
What they that I'll go to Chivilcoy? Yes, maybe before the end of the year, Maxi. I can go to visit you, of course.
Of course.
Prepare you, prepare the asado. Yes, prepare the barbecue.
Yeah. Ah, we
Prepare the
lost your video.
barbecue.
Yeah, the
Sure,
barbecue.
yes.
Now I gonna need a late night
In
snack.
2 hours, I can go to where is Maxi, where Maxi Observatory is. Yes,
Mhm.
Awesome.
no problem.
All right. Yeah, you guys
Alrighty.
could do a global star party together somewhere. So
Yeah.
that would be a lot of
Yeah,
Yeah.
yes, it's a good
That would
idea
work.
on Tuesday. Yes, no problem.
Okay.
Yes,
All right.
I can make that.
Next month, maybe.
All right.
Before
December, yes,
before the 8th of December,
yeah,
Yeah.
okay,
maybe.
okay.
Well,
Yeah.
uh,
You know what you need, Scott, for your global star parties? You need a DJ that's gonna play
oh,
closing time.
Closing time.
Yeah,
Or
yeah.
You'll have to
as
hear me
we're
sing, and then
finishing our
We,
we'll go to
we
another
need-
global star party after
we,
that.
we need
So
a alarm
Yeah.
to say stop the star party, close.
I could just pull
they
the
could-
plug, and that's it. You know.
Yes,
Yeah.
because if not, we can still talking at 4 a.m. Yeah,
mhm.
That's true. I know you could.
Yeah.
I know
Here
that
it
maybe
is.
more.
absolutely.
All
Here's
right.
the song.
Okay.
Take care. Have fun, and be well, everyone. Take care.
All
Okay.
right. Take care.
See you guys.
Bye bye.